Thank you for coming and welcome to Machine Learning Conference 2024. My name is Željko Crnjaković and I'm the manager of Inspira Hub, which is a part of Inspira Group. And basically Inspira Hub is a co-working space and a event space for the local community. This is the fourth conference, machine learning conference that we are organizing, and we are very happy that each year we have more and more people coming. Somebody said that this is the best small conference that is very, very technical, so professionals for professionals, and I'm very glad to see that each year I'm seeing more and more professionals in the fields of data science, machine learning, and artificial intelligence. So I want to tell you, so basically, Inspira Hub, we celebrated 10 years of co-working in Subotica last year. So this is the 11th year. We were the second co-working space in Serbia, and I'm in our community, I'm being described as the stubbornest man in co-working. And that is because throughout the years we started, and you know, the first co-working space, I opened it, nobody came, and then a few months later, 2 people came, and then 10 years later, we don't have any room. So when we first organized the conference, well, we have had a lot less people. So every year, I'm hoping in 10 years we won't have room for you. But as in co-working, I do say that we have nobody that it doesn't matter that if they came yesterday or 8 years ago, we have the best community. And I'm really seeing and hoping that machine learning will also have one of the best communities in Subotica, in the region, in Serbia, and basically that this place, that Subotica isn't striving to be the center of data science, machine learning, and artificial intelligence, but we are striving within Inspira Group to make Subotica one of the key places for exchange of knowledge and experience for these areas. And in that, and through my speech, you may recognize that I am not a data scientist. I am not a machine learning person, even though we can't escape the artificial intelligence topics anymore. But when I talk to people, I talk about how we use ChatGPT for copywriting and stuff like that. And when people ask me, and what is this conference? Well, in this conference, people talk about how to change the oil in ChatGPT. So to help me organize this, I'm very thankful for our partners and our sponsors, of course, and partners, but the key partner is Association Machineria, from which Goran Milovanovic was the key program coordinator, along with Mikhail Roskov. Mikhail, where are you? Please stand up. There he is in the poster section. So Mikhail and Goran were the key elements in creating this wonderful program that we have for you for 2 days. So I'm going to ask Goran to talk to you a little bit about the program itself. What can you expect in the next 2 days? And then I'm going to tell you some logistical information, what you can do throughout the conference, what you can expect throughout the conference, and what are we going to do tonight for the party. But Goran, if you please.
Thank you. Thank you very much. Thank you, Željko. I will not take too much of your time. I am addressing you as the president of Machinery. We are, for the first time in this 4th edition of the ML conference, the co-organizers with Inspira Hub. Through this cooperation also, Inspira Group and Inspira Hub became even formal sponsors of Machinery, and I wish to thank you for that, really. It doesn't take too much money to run a professional community. And that is the reason why we are always very, very thankful to people who actually contribute a little bit to our work. Okay, so Machineria, you might know or not, but probably most of you in the community know, we run the Data Science Club series of meetups in Belgrade and Novi Sad, organize mini conferences. Last year we started by organizing one very nice event, I would say mini conference together with the UNDP on the topics of generative AI. I would say approximately at the time when the whole topic actually exploded. Yes, our role in the organization of the Machine Learning Conference 2024 was actually to be the program board, to put it that way. So we were the selection committee, etc. And also Mikhail Roshkov, who also runs a separate community called Machine Learning Grepa, specifically oriented towards MLOps people, machine learning operations people. He also contributed by actually editing and selecting that track. So the program, we will today first focus on generative AI things, okay, mostly. Then, after lunch, I would say we will switch to machine learning operations, so the people who actually, you know, make the software run. Very important part of the whole story. Together, we will conclude in a panel which will be organized at 5:30, I believe, okay? Tomorrow, we are entirely focused on AI and generative AI topics. And later on, for the first time, I would say in the organization of the Machine Learning Conference, we will have a section with 3 talks about broader topics and the consequences and even societal consequences, ethics, regulation, management of AI projects, managing risks related to AI projects and similar. I find that to really be very important because we are obviously witnessing a time where technology is influencing societies way more than it maybe influenced them before, or at least in a completely different manner. So, you know, welcome. What else to say? And by the way, yes, this is the best small professional conference in Serbia and the region. Thank you.
Thank you, Goran. Okay, so before we start, I would like to thank everybody who made this conference possible. And first of all, so to all of our partners, which you can see on the screen beside me. So apart from us and Machineria, so we are supported by Inspira Group, Data Collective, IT Subotica 2030, IT Cluster, ML Repa, Hello World, and EPAM Systems, our sponsor for this conference. I would like to ask everybody to notice these QR codes. We have a couple of posters around the hall, you can find them. So if you submit a form, so your information, so this is from our sponsor, and this is a raffle for everybody in the audience, including speakers, except the staff. So, so if you enter your information, tomorrow, after the first block of the presentations, we will have a raffle, you know, selector, and the winner will take home this Lego set, which is very cool. I would like the staff that they, you know, to involve themselves, but we cannot. Yeah, you are a speaker, you can. So, so thank you, EPAM, for providing us. So take a look at these QR codes. We have them a couple of places. So for some logistical information, so the coffee is next to the registration. You also have a coffee vending machine at the end of this hall. Everything's free. Everything's, you know, you just select, take, and take coffee. In this conference, we have one new thing apart from everything else. We have the poster section in this room where the lunch will be later on, but we have a couple of poster teams which are not speakers. They are not included in the speaking program, but the teams provided posters for their projects, which can be research or commercial, whatever, you know, whatever they developed using data science, machine learning, AI. Take a look at them. The teams are here to answer any and all questions. So it's a very good way to, you know, have some extra content apart from the talks that we prepared for you. During lunch, I would ask everybody to bear with us because lunch will be here, but the only way to bring in lunch is here. So once we start the break, so just bear with us because we have to move the lunch through this hall into that, and then we'll have lunch. In the evening, we're going to an ethno house, Majkin Salash, on Palic. We have an organized transport which starts at 2 times 8:30 and 9:30. You received your times. Who could selected, who couldn't, didn't. So please come at the time that if you are coming by bus, come at the time that you selected, because the bus can only hold 50 people. So if 80 people show up for a bus, 30 people will go by taxi. Sorry. The bus stop is when you go out the main entrance of the hotel and go on the line of the hotel, at the end of the street, you'll see on the left a ramp for public parking. Before the ramp in that street, there will be a bus. So, but we will have our volunteers, somebody in this t-shirt at the spot. So be punctual. So 8:30 and 9:30. And we are coming back by bus also at 12:30 and 1:30 in the morning. So also, and that's going to be messy because I'm not giving you times, so everybody can decide or come on your own. Okay, so if you have any questions, find me, find anybody in this t-shirt, and we will answer any and all of your questions. Throughout the day, we'll have our host, Mihailo, who will introduce you to all the talks, and I hope you enjoy today. I also want to tell you that we have 2 online sessions. That was unpredictable, but at the last minute, 2 people couldn't actually be here, but it will be live online sessions, so there will be Q&A involved. It will be the second session in the first block, which is Nebojša, right? The second talk. Nikola Milošević from the Institute of Artificial Intelligence, and Angelia Masnikoza later today from Meta, who is actually a person from this hometown. So Subotica will be joining us from the United States on Teams. But again, it will be a live session. You can ask questions. Everybody else is here, so you will be able to basically ask anybody any question. I think that's all. Enjoy today. Thank you for coming, and welcome again to Machine Learning Conference 2024.
Thank you. Thank you, Željko. So, dear participants, welcome once again to the Machine Learning Conference 2024. Without further ado, we are proceeding with the conference program and our first talk of the day. Our first speaker is Nebojša Bjelotomić, CEO of Digital Serbia Initiative. Nebojša graduated from Boston University in the field of biomedical engineering. His career took him from startups and big corporations like IBM and Fujitsu Siemens to actively supporting Serbian startup teams in their efforts to expand globally as a business angel. And in 2021, directly participated in 2 investments valued at €500,000. Since October 2021, he has been leading the work of non-governmental and non-profit organization Digital Serbia Initiative. He will talk about how AI is being used in day-to-day activities in most businesses, what are the benefits of AI in workplace and the challenges for effective use, as well, is AI a chance or a threat for Serbian economy? Nebojša, the stage is yours.
Thanks. Hi to everyone. Few things. The fact that I'm in a suit is just the fact that I got scared with the keynote speaker, and usually I'm not in a suit, so just not to have a barrier between you and me. Second, what the guy said I'm going to talk about, I thought that something else might be more interesting, because usually the keynote guys, at least the conference I've seen, have a kind of fall in 2 categories. Either they have a really big name, a lot of things they did, and it's really admiring their opus. And by being in a keynote, they actually add to the conference, which is obviously not my case. A second one is they try to be kind of somehow intellectually stimulating, asking the questions that you don't expect. And that is my presentation today. So are we on? Okay. So I actually never watched the show that refers to winter. So it's not about that. The winter is about another thing. If we're talking about AI, I assume that here I don't have to go into much details, that actually the whole concept has been around for about 70 or so years. Actually, back in second half of 50s, a group of people went to Dartmouth College, got together, and started actually writing the papers about many things we are doing today. They had one mistake. They said that hardware will be around to support what they were thinking about in about a decade. It actually took about 60 years. And actually, out of that group, one interesting thing also happened is that Professor Minsky was actually also advisor on Odyssey 2000 movies, and actually he's the guy who created the whole concept of HAL, you know, the first artificial intelligence in public eye that actually managed to kill all the people. So I guess that put a lot about, you know, general opinion about what AI will come to be. I mean, like a super intelligent species that, as species always compete with each other, will find humans something that is, you know, not worth being around, or at least not something that you should care about. And that's where, you know, general public and I became to have this really odd relationship where we are kind of want to have it, but we're really scared about having it. But what the first group of guys did in these late 50s, early 60s is they managed to overpromise. They talked about AI as something that will, you know, completely change society, completely change the mechanics of society, you know, the marginal cost of labor and everything else. And, you know, they start getting obviously a lot of attention, some investments, but after they didn't deliver, actually no change happened in some time. We have the first, what they call nuclear winter of AI. Actually, you know, it was almost that in 70s, it was embarrassing to mention that you did something on AI in 60s. And then, you know, without far from the public eye, but obviously the research continued. So we entered the 80s, and then we got the rise of expert systems. And expert systems were pretty cool. Actually, there was a lot of things that expert system could have done, except that expert systems, you probably know, you had to be very detailedly encoded about what you want to do, and then they can actually automate some of the things. And actually, probably the highest moment for expert system came in mid 90s, where actually then a chess champion was beaten by IBM computer, and that was televised for whole world to see. And that was one of the moments where people were like, "Oh, this AI has finally come." Just about that time when the Gary was losing the chess match, I guess the financial types got fed up again with AI, because for the last 10 or so years they've been putting a lot of money in AI. They haven't seen any production going up in the companies. So we have another nuclear winter. That nuclear winter was like end of 90s, beginning of 2000s. Then somehow called Canada became a hotbed for AI, and they came up with a deep learning, and a lot of things started happening again very positively, and we got to the point where, you know, AI started again promising a lot, to the point that probably last year and a half we live in one of the biggest technological hypes that we've seen in last century, of if not more. Yeah, I kind of find it really funny that one of the defining moments of the new hype era is that actually AI managed to beat humans in another game of Go. Lee Chebol was beaten it was now 10 years almost ago, and that was like one of the big moments, because as opposed to chess, which is all about computation and combinations that are limited, Go is apparently, you know, you have unbelievable amount of moves, very quick, actually even invent the moves, and the deep mind, the Google's, not then Google's, but now Google's machine actually invented a move which was amazing, and that was a proof that AI have finally come, at least in the eye of the public. And then, you know, actually another thing happened during this time, and that has nothing to do with science and nothing had to do with the AI. Actually, in last 15 or 20 years, we have a rise of retail investor. What is retail investor? Retail investor is pretty much all of you. So, you know, back in 80s, you know, only really people who knew anything about investment were going to stock market. You probably needed a license to do something on the stock market. Stock markets have been around for, you know, centuries, nothing new about that. But just actually last 10 or 15 years, actually more and more people, lay people, started putting money into investments. First it was in funds, but then they start picking the stocks, and then automation of the trading actually is something that kind of attract a lot of people to try their luck. Is something of their domain knowledge, something that they can predict the rise of the stock or not. And out of that, we got really hype cycles for several what people like to call frontier technologies. So back in 2016, 2018, if you were in a corporate world, your shareholders or your boards were going to you and saying, I don't care what you do, it doesn't matter how you do it. Is it a platform? Because platform was the business that was about to change the human world. They actually even came out with a word that nowadays probably nobody knows what it means, Uberization, because apparently platforms are supposed to be these things where if your investment is very asset light, so you don't have to invest a lot of money, you actually make a one meeting point where people who have some needs and people who can fill those needs get together, and you take a cut from transactions that they make. And that's beautiful, perfect, and actually that whole era is probably defined by Zuckerberg's sentence, move fast, break things, where actually they were advising people to find area that law is very outdated so that you can actually ignore the law and bring some economical advantage, and then you're going to make a lot of money out of it. And that was like 2016, 17, 18, and then somehow platforms are not so cool anymore. I mean, Uber is still around, Airbnb is still around, but it didn't really change the world, didn't really change the things. And then another hype cycle happened just several years ago. Actually, the origin of the story is some 10 years back, but then crypto and the blockchain became a huge thing, huge thing. Again, investor had something to do about it. One of the most, let's say, prolific investor, Anderson Horowitz, created their own fund that was several billions, and then every single VC around said, did I invest in blockchain? Do I have blockchain in my portfolio? And we've seen the valuations and investment in a blockchain that were really unbelievable. And of course, these retail guys that I mentioned wanted to cut all of that. So a lot of these spikes in valuations and money flowing in were just from people like you and me who are putting their 1,000, 2,000, 3,000. But when you put millions of people, it's a lot of money coming into this area. And then, then we got the preachers of AI, the guys who are really good with the words that came not really from AI world, all of them, but they got really good in hyping the whole topic. So no need to introduce Sam Altman, the guy who said that in a podcast in 21 that in 20 years from then, which is already 3 years, the artificial intelligence will be sending missions to space. And it will completely take over human society. And then the guy who broke from OpenAI, Dario Modeo, in a podcast like 2-3 months ago, said in next year we should be scared about AI creating the bioweapons and having a cybersecurity attacks that can compromise the safety of the entire planet because they're going to get so smart, right? And all of that is based on LLMs that they kind of just stumbled about several years ago. And, all of that had an influence on actually, getting the money. So OpenAI was so successful in actually collecting the money that they collected, about $13 billion. Actually, one of my favorite catches for the brain is that, about the time where Microsoft invested the first billion in AI, they also invested $1 billion in quantum computing. Actually, when they acquired LinkedIn, one of the guys from LinkedIn became a CTO of Microsoft, and he said, you guys are going to be like surpassed by technology trends, and you have to invest in these trends. And they invest in the quantum computing and invest in AI. Except that this guy, like in the previous slide, was so successful in convincing Microsoft that to give another 13 billion, that now all of us are we using AI? How much are we using AI? And subject of my topic is supposed to be how much businesses should be using AI, and in Serbia is going to dissolve because of AI. Imagine if they put 13 billion in quantum computing. All of us will be, how many qubits do you have? You have 10, you have 20. How many access you have to qubits? Imagine, we will all be talking about qubits. If, for some reason, 13 billion didn't go to AI, but went to quantum computing. And then, that is not the top of the madness. Top of the madness is what's happening last 2 or 3 months. Actually, so Microsoft, by investing all these billions, became the most valuable company on the planet. there's something called market capitalization, and that means that you take value of all your stocks and you multiply number of the stocks, and that's one number that has no meaning. And there's only one more stupid thing than market capitalization. That's the value of a startup. So market capitalization doesn't really exist because the moment you start selling the stocks, they're going to go down. But anyway, with trillion of value, Microsoft continued investing, and then other guys wanted to get on the action. So Amazon and Google, not to be outdone, 2 months ago invested $6 billion in Anthropic, and they bought all the money invested, they bought about 10%, so they put the value of Anthropic to 50 billion or something like that. And then, Europe don't want to be left behind, so the Mistral got investment of 500 million, and so on, and so on, and so on, and billions went into the AI. And then, with OpenAI being what it is, kind of comedy, kind of drama, I like, and I put on this slide, actually, that Microsoft invested 2 months ago into taking a team from a company, 620 million. Imagine you have a company, you run your business, and somebody comes and says, I'm going to take a part of your team, and officially I'm going to license your product, but actually they're going to take a half of your team, and they give you $500 million for it. Not a bad business. So actually, that happened when it was March 2024. And then, of course, the guy who prints the money whenever he wants raised $6 billion beginning of the week, which is kind of, I don't even can choose the proper wording for that. But obviously, money is all around AI. And then, I don't know, I always wonder, is all this stuff that we read from all these smart people who analyze and consultants, do they say this because money is already invested, so we can expect something to happen, or because if all these guys are being so smart investing the money, something must be going on? But anyway, we are being introduced into these crazy numbers that 68% of all the position will be affected by AI, 22% will be affected by this or that. I mean, I always wonder how they come up with these numbers these days. Probably the answer is they ask ChatGPT, but anyway, we got a lot of these guys who've been saying, if you don't hold on to this train, you're going to fall off the planet. And the question was always, what comes first? Actually, when they asked me to send the presentation, I waited for the last minute because I wasn't sure what should be the first slide, this one or this one. What comes, what influences what? Is this really the truth? So all the people are investing, all the people invested. So of course, consultants have to make their investments very valuable. But then, all of this, and you know more than me about this, so I feel uncomfortable talking to you about this, comes on the fact that we have these LLMs that actually are, a fact that gambling have win the day. Because all these models that they actually do predictions. No reasoning, no planning. We claim we have intelligence, but reasoning and planning that should be the most important things for our intelligence are not included in these LLMs. Actually, we take a sentence, we take 3 words out, and we put a lot of data so that we can predict the 3 words that took out. And if we put enough data on it, we're going to get the right outcome, unless it will hallucinate, which happens in 30% of the cases, so it's not really reliable. But another thing that kind of is crazy, I assume, because we are all obviously buffs about this topic, you've seen Zuckerberg claim that he managed to get 350,000 GPUs from NVIDIA. You understand how many billions of dollars that is. And all of these nodes will probably use more electricity than not Serbia, but entire Balkan or who else. So actually, it doesn't come as a surprise that one of the hottest news in May, I think, was that actually Microsoft started investing in energy, renewable energies. Actually, 10 billion was invested into buying something that produces energy, because if you're going to run all these GPUs, you have your own energy in order to control your business. So actually, out of need to support LLMs, we now need all this energy that we run the data centers. And then, of course, not to mention that actually all the money that Microsoft so far invested in people is dwarfed by amount of money they're investing into creating their own processor, because who wants to depend on NVIDIA for everything, right? So, Microsoft is expecting to have the processor coming out by the end of the year. Actually, again, Dario Modei said that currently we have models that are worth 1 billion in training, but he expects that in a year or 2 years, we're going to have models of 5 to 10 billions. I mean, I don't know if you can wrap your minds around all this money, because if you ever had to invoice anything, actually invoicing 1,000 euros is a very difficult work. You have to have many meetings, you have to do a lot of presentations, and you have to do some sales, or you have to code. But 1,000 euros to actually make a revenue, it's a significant amount of money. We're here talking billions, like we're talking peanuts. So quite interesting is that is this whole hype coming because we are so sure it's going to happen? Or if you go back to this, so this was the first Microsoft investment, then there is a second Microsoft investment, and there is a third Microsoft investment. And in Serbia, we have this sentence that I tried really hard this week to translate, but you those who don't know Serbian, ask somebody around you. Nije ga majka karala što se kladio nego što se vadio. It sounds like that. It's about gambling and trying to recover your debts. But anyway, this is the state, if you look as a business person, into what is happening in generative AI. And then I hope you guys are going to talk about all the hallucinations, all of the lack of reasoning and planning. And, one thing that is interesting, because as opposed to our countries, I mean, in other countries, they have actually newspaper people who can ask questions. So when these guys come onto shows, they ask them, do we need better models? Do we need something else in order to really get to AI or general AI? And all of these guys from the pictures in the previous slides say, no, this is it. Because if they say, yes, we do need new things, then of course the question is why they took money for. But do we need other things than LLMs? Are LLMs something that is really binding future of AI? We all here because not only we find probably interesting and somewhat profitable to be in this field, but we really like it probably. And all of us are believers that AI will influence the human future, maybe not in 5 or 10 years like the investors would like, but in coming decades. So I've seen generally it's a young audience, so we will be around to see the changes. But is it LLM really the way to go? Is that something that will really bring a new winter? Because the overpromise happens and all the billions went into all the companies and they are not going to introduce the productivity that is expected by the finance people. And then, of course, all the research will continue, but without fanfare, without media attention, without money. And then it will take another couple decades until finance people again want to give the money. Or is it something that really changed the world? And like what Sam said, 10 years will send mission to Mars without humans, but more intelligent than humans. And then, another really interesting topic that I found as a kind of, as a species to claim to be the smartest on the planet, we have this unbelievable habit of repeating the mistakes. And actually repeating the mistakes quite often, and I mean the same mistakes. And actually, I've seen half of this slide in the presentation of Zef, the guys who are making electrical motors here in Serbia for German cars. And this is kind of interesting. So first patent for the car came in 1886 by Daimler, and Benz about the same time invented the car. And then Nikola Tesla, and I'm really happy that was at him, got a patent, actually submitted the patent for electromotor in October 87, so about a year and a half. So the first car with, let's call him electrical car, came to be about a year after the cars were invented. And now, fast forward 150 years later, after numerous environment disaster, oil spills, wars because of geopolitics, carbon emission and all of that, we are going to switch to electrical cars. I mean, at least even if you don't want to, the lawmakers are determined to make a switch to electrical cars. So, if I think about AI and LLMs, I'm kind of sometimes wonder, do we have this oil versus electrical motor moment here with all the money going into LLMs in the next several years will actually put us on a path that will, in 100 years, with all the minuses and negatives that we have in our society, we'll figure out that, some of these methodology that we're using right now, and I'm kind of almost afraid for you to use it in front of you because you know it better than me. It's something like reinforced learnings or supervised self-study. Are these really the things that are good? And is the fact that we are basing intelligence on language that is a construct of reality, not reality. You know, you don't have language until first year, yet you learn how to walk, talk, and do things around, including eating, which is really important. By the years of 4, you probably took more information through your eyes than these fancy billion-word models will take throughout all their trainings. Can we use methodologies such as reinforced learning on pictures? How does it look? So we take a movie, we take 5, frames out, and then we're gonna train it to recognize the frames. 10-year-old can pretty much set up the table and clean the table before and after the lunch. How are we gonna teach artificial intelligence to do something as spatial and visual? And we yet claim we're gonna send mission to Mars in 10 or 20 years. I mean, where is the reality, where is the investment, and where we should go? I mean, yes, there is definitely fortune under the pyramid, but are we going the right way? I mean, as I stated in the beginning, so not the name that you can bring the really value, but maybe I can get you to think about things and directions. So that was my talk today. Thank you very much for attention, and I enjoyed the conference.
Also, before Nebojša leaves, there's also 5 minutes time for Q&A if anyone has any questions for Nebojša.
Shoot if you want to argue that I'm completely wrong.
There's a question over there.
Platforms were, thank you. At some point in your talk, you mentioned that platforms were hot at a point. And then you added, but then there was a disappointment in a sense of like platforms didn't change the world. But I was thinking, Nebojša, I'm not sure platforms did change the world. So I don't know if I know a single person who is not using Airbnb, a single person who, okay.
No,
but listen, you're a CEO. And,
the question about platform is the following. Platform had one wrong view of the world. And that is that, for example, Peter Thiel was saying that we need to invest all the money in Uber so that Uber kills all the competition. And once the Uber has only, the service out there, then that is going to raise the money, raise the prices and the profits, which only happened in the last quarter of the previous year. So for 15 years was making minus. And actually what, these guys completely were mistaken. Uber never managed to kill anyone, not even in the United States, let alone China or Southeast Asia. So we have cohabitation of the platforms, and the profitability of these platforms is very questionable, let alone the fact that they're really questionable how much they're acting by the law. So we see that London is killing it, Rio is considering killing it, and so on. I mean, it didn't die sudden death, but definitely did not bring, the first investors obviously got a lot of money, but afterwards, the probably pre-IPO guys, got their skin, they should have taken from their skin. So the thing is that it's not what it was built to be for sure, at least not for the investor folks, and not for society for sure, because yes, we've seen some benefits. We can probably argue that, for example, Airbnb influenced the fact that GDP worldwide, contribution of tourism to worldwide GDP is about 10%. So people will travel much more. But also, we can talk about many negative things about Airbnb in a sense of gentrification of the entire neighborhoods and overwhelming pressure on the infrastructure of some of the cities because of Airbnb and not enough taxes being paid by these people traveling to contain the cities. So platforms are not hot for investors for sure. They might invest in some, influence some of the human habits, made some things more available. But look, the fact is that, for example, in the United States, under 25 people have a lot less driving skills than people above 25. So what's going to happen if Uber doesn't exist? How going to get around? So
it is a questionable.
Yeah.
And just another thing. So how would you comment on the following? So this is going to be just another in the line of numbers that you mentioned on this research on how AI influences things, the societal changes. So, I've seen numbers in the span from 20% of jobs will change and 60 or 65 jobs will change. So nobody's really getting the number with that standard deviation, obviously. So I also have doubts about the actual sources and how do they do it. I think only yesterday, or maybe the day before, BBC published the results of a research on, I think the sample size was more than 10,000 or so respondents in, I would say, United Kingdom. I'm not sure. The result, less than 2% of the respondents use anything like ChatGPT on daily basis in their work.
Well, there's obviously Chicago school is more conservative in terms of economy, and one of the professors actually offered to bet anyone who will put the money to claim that in the next 10 years we'll actually see the benefit in productivity in companies. Because, look, one thing is what is rational and what looks good. Another one is human perception and adoption. I mean, I don't know how many of you here, anyone try to sell CRM or ERP to, small and medium company. I mean, the people who know everything and hold everything in small notebooks, and then you come and you tell them that, they should automate and digitalize, any of that. It's very difficult. And these guys, usually they don't know where the mine is during the day because they have so many tasks that they have no time to actually invest in new technology. The funny thing about AI in terms of business is that usually early adopters of the new technologies are small companies because that is source of their competitive advantage. AI is complex to the point that small companies are not daring to do anything with AI in their processes, and big companies take time. So usually the big companies, because when they start investing in something, because a lot of people or the resources, actually they have bigger impact. So I do believe that in a decade or so, we'll see the huge impact of some of LLM effects. It will come from the big companies. I think SMEs don't dare play around with AI because just they feel that they don't understand it. Especially the fact that hallucination, look, 20% or even 10%. You mean that you screwed up every 10th or every 5th of your customers. And if you're a small company fighting for your survival, messing up 20% of your business is not something that you want to try.
Thank you.
Any other questions? Okay. Thanks.
Thank you, Nebojša. Okay, so our next speaker will be joining us in a live online session from Germany. Nikola Milošević has a PhD in natural language processing from the University of Manchester. He worked on several projects involving information extraction from tables in publications, automatic identification of social innovation, music generation using recurrent neural networks, de-identification of clinical records. In 2020, he moved to Berlin to start working at Bayer Pharma Research and Development as an NLP scientist. From 2023, he is working with Institute for Artificial Intelligence Research and Development of Serbia, where he leads several initiatives in NLP, including EU-funded Verif-ai project. Nikola's talk is Verif-ai project, generative search engine with referenced and verified answers for biomedicine. Large language models can produce convincingly looking answers that are not correct. This phenomenon is called hallucination. In sciences, especially in biomedicine, hallucinations are not acceptable. Therefore, we present Verif-ai project that aims to provide question answering engine in biomedical domain. It is believed that the Verif-ai will contribute to establishing trust and democratization, better and safer use of generative AI in scientific domains, and therefore foster future scientific exploration and discovery. So Nikola is taking the stage.
Thank you very much for this great announcement. I'm sorry that I could not be with you, but we had a recently baby, so I unfortunately am presenting like this in Berlin, and I couldn't join you in Palić. But yeah, I will be presenting Verif-ai project. We kind of played a little bit with words. That instead of Y, we put AI. And yeah, it is a funded project by NGI Search Initiative, which stands for Next Generation Internet. It's EU project, and yeah, like basically what it is generative search engine with reference and verified answer. However, we're going to move on a little bit on how it works and why we did it. So yeah, like large language models have this kind of like problem of hallucination, so they can produce answer that sounds like very confident, coherent, and articulate, so people are easy to like believe them and trust them. However, the information that they are conveying may not be really like correct or verified or have kind of like any source, or they can be even kind of like totally false. So basically, like how large language model work, like they are basically next word predictors based on the distribution, and they predict the next word based on the distribution that can be commonly found on the internet, and it is a little bit guided by the prompt that you give it. However, it cannot be really said that it can reason. There is a lot of papers proving that they cannot really reason or they cannot really plan, and they can just kind of like provide you the information they have already seen, and therefore it is like basically we believe that it is basically next word predictor. So it does have limited internal knowledge, and this can hinder their ability to deliver factually accurate answer, particularly in specialized fields. And as well, like quite often large language models have a hard stop when they were kind of like trained and fine-tuned. So like new information they would not be able to provide unless you give them somehow this information within the prompt. So this is basically noticeable concern in biomedicine. So like in medical domain, you really need to base your decision on accurate and factual answers. And it is like really not acceptable to have any kind of like hallucination. And as well, like what we are trying to achieve with this model is kind of like aim in privacy, sovereignty, and security within like pharma and biomedical industry. So quite often we are dealing in biomedicine with patient data that are kind of like secret and they cannot leave the system. And you cannot really use OpenAI or other APIs where you don't really know what happens behind and what information gets saved, what the information get kind of like used in which way and so on. So like you really need a controlled system all the way through. So like you need to control the infrastructure and as well the model, and therefore, yeah, like these like very large language models that can be accessible only via API are not really acceptable. So yeah, like when it comes like what can we do when it comes to hallucinations? There are like a couple of techniques. Like there is retrieval augmented generation. You may have heard of it. So like basically within the context, you can provide the documents. This reduces the hallucinations. However, it does not guarantee that there won't be hallucinations. And especially it really depends on the search engine, like how well it retrieves the documents. And I can give you just like an example where it made it wrong. So like we had a use case here in Bayer where we used RAG for some kind of like cellular reprogramming within liver. So we asked the question like what genes can be used for cellular reprogramming in liver. And the retrieval somehow got the document about cellular retrieval in pancreas and spit the genes out that are pancreas related. However, it spit it in a confident way that it looks like it is for the liver, but it was like different organ. And therefore, the information that was provided was totally wrong. You can fine-tune the model so that as well kind of like biases the model towards the information that you want to give. So you can give it some kind of like reinforcement learning with human feedback or so, or like based on some training data. You can provide the sources, and obviously what is kind of like the main contribution of this work is kind of like have a posteriori check of the model. So how our system looks like is basically this diagram. So we have a user that is on the right side here. He will ask a user query. We have some index or like basically information retrieval engine that is like this big box that uses basically PubMed data, so that are abstracts in biomedicine containing like about 40 million abstracts of the papers published in biomedicine since 1940s. And we use like MS Markov model for like vectors, and but as well like we use basically combination of semantic and lexical search. So like there's open search for lexical search and quadrant for semantic search, and we kind of like combine them. Top 10 abstracts are provided to large language model, and then basically the response is generated. This response together with the documents previously obtained are kind of like passed to another model for posteriori check, and in this posteriori check, user can see flagged document like claims that large language model made that may not be completely based on the initial document. So yeah, like basically Verif-ai has three components. So information retrieval, generative component, and verification engine. So like we'll talk a little bit about each of them. So information retrieval engine basically retrieves relevant articles for basically generating this claim. As a source, we use, as I said, abstract, and mainly we use titles and abstracts. So we concatenate them. We excluded abstracts that or articles that were missing abstracts. So we had 5 to 10 million abstracts that had only the titles. And usually these are like very old abstracts, so they may not be really relevant. And then like we index them within the yeah, like both engines. So like for lexical search, we use the full documents, and for semantic search, we have the basic problem because we are using transformer models for creating embeddings that have maximum input size of 512 tokens. Therefore, we needed to kind of like segment the documents or chunk them. So they have kind of like maximum length of 512. We kind of like segment them on the last sentence. So like kind of like a last full stop before 512 token would be kind of like the breaking point where the documents would be chunked. And then, yeah, like in the lexical search, we use sparse vectors. Algorithm is kind of like provided by OpenSearch, so it's BM25. And we use some metadata like authors' names, publication dates, and journal names. And as well, like everything was built on OpenSearch. We wanted to find initially an engine that would allow us to do both lexical and semantic search within one software. OpenSearch seemed like a solution. It is kind of like fork of Elasticsearch made by Amazon. And it has within it kind of like implementation of FAIS, so like Facebook's vector database. However, the problem was that the vectors in the lexical search could only be saved in the memory. And given that we have like over 25 million documents, they could not fit into reasonable amount of RAM memory. and therefore we needed to give up on using OpenSearch for like vector store. So then like we use basically quadrant vector database because it allows part of the index to be stored on the hard disk, while kind of like the most search document or like most relevant still are in memory. So it kind of like allows fairly fast retrieval of the documents despite part of the index being on the hard disk. So yeah, like we embedded everything with like transformer model, which was based on this which was fine tuned on MS Marco dataset. So like MS Marco dataset, it's important to mention that it is like the fine-tuning methodology or basically a data set provided by Microsoft, provided by Bing, basically Bing queries and the documents that kind of like fine-tunes the model to allow asymmetric search. So like you can have like short query and longer documents. And quite often, if you are using sentence embeddings, you would have a problem if you have like asymmetric kind of like document compared to the query. So you could either kind of like compare sentence to sentence, but not really kind of like full document to a sentence. However, kind of like that is overcome with this like fine tuning using MS Marco dataset. And yeah, like vector store uses this hierarchical navigable small world indexing technique, which is kind of like a graph, building a graph out of the documents. And then like based on that, search is working as kind of like dot product and finding approximate nearest neighbors or clusters of nearest neighbors. In order to as well like make retrieval faster, we use 8-bit quantization. So like usually you would have like 16 or 32-bit vectors. So like based on the basically standard kind of like float. However, like quantization is basically a technique where you can kind of like fit basically numbers in a smaller number of bits, and therefore kind of like make it faster and save basically RAM. And with that kind of like fit more into the RAM memory, and therefore yeah, like it works much faster. So yeah, like basically we then out of those kind of like build hybrid search combining lexical search and semantic search. So lexical search would kind of like help identify direct matches, and while kind of like semantic search would allow discovering semantically related phrases. So basically kind of like synonyms or things that are phrased a little bit differently, but have more or less similar meaning. However, because we use like two different softwares and two different systems, you would get kind of like retrieval scores for the documents that are completely different in a different range. So we had to normalize it and then kind of like add weights. So like basically all these numbers that came out, we normalized to numbers between 0 and 1, and then kind of like added to these weights. We did some experiments. You will see later results, but the best combination on this like BioAsk data set was that we have like score of 0.7 for lexical search and 0.3 for semantic search. And then comes this like generative component that retrieves relevant documents from information retrieval engine, and then utilize a fine-tuned large language model for answer generation. So like we as well like generated a data set. So basically, we started with this like PubMed Q&A data set that contains a number of like quite huge number of questions, kind of like semi-automatically generated from like PubMed abstracts that have a question mark at the end, but as well some 2,000 questions made by experts, and as well like there are 2,000 of those that were annotated by the users, the experts. And we use those 2,000 and kind of like additionally randomly selected some documents that were this like automatically generated to create about 9,000 questions. For each of these questions, 10 relevant documents, 10 relevant abstracts were retrieved from PubMed repository, and we use GPT-4 Turbo for creating the answer based on these like retrieved documents. And yeah, like GPT-4 Turbo is quite good for generating those answers right now, but yeah, like we kind of like want to, the main goal is to replicate what the GPT-4 Turbo does in like much smaller model and in a model that can be hosted in kind of like sovereign and kind of like safe environment. So like we don't need to use Azure or OpenAI APIs. And we use this like prompt that like answer the question using relevant abstract provided with like up to 300 words, and reference each statements with the provided abstract ID in brackets next to the statement. And yeah, like we then kind of like fine-tuned Mistral 7 billion parameter. We had like two kinds of Mistral was provided, there were like two models provided at the times. So like there's version 1, version 2 was released recently, and now we have as well like version 3 from I think a week ago. But yeah, like we still didn't try version 3. And yeah, like we split this PQI ref dataset that we created in 80-10-10. So like 80% for training, 10 for validation, 10 for the testing, and then we use this quantized LoRa methodology. So like LoRa is standing for low ranking adaptation, and it is methodology where you build adapter to the model basically by fine-tuning two vectors that by multiplication kind of like create a vector, and this vector is then kind of like added to the output of the large language model, or to the weights of the large language model actually, and by that kind of like moves the weight in the direction that you need it. And by that you kind of like fine-tune the model without actually touching the original large language model. And it is quite handy because you can have like multiple adapters while in memory having only a single large language model or original model. Foundational model, just kind of like exchanging or loading different adapters at the different times, and yeah, like these are like hyperparameters that we use, and as well they are kind of like quantized, so as well like we can kind of like make it all smaller by quantization. It was all fine-tuned in like National Data Center in Kragujevac on this like a 140 gigabytes GPU, and the training took about like 32 hours over 2 epochs using batch size of 1. Yeah, like that was basically how we kind of like generated the answer. Like then we used that for inference in the same methodology, just by kind of like providing the top 10 documents from information retrieval engine. Then verification engine, basically the aim is to cross-check the generated claim. So basically we split the documents whenever there is a reference. So everything before reference or sentence before reference is kind of like checked against the abstract that is referenced, whether, yeah, like that answer is based on it. And this kind of a task was first known as natural language inference. However, like now with large language models, it started changing in name. Sometimes it's even called fact-checking. I don't really like the name of fact-checking because you don't really check for the fact. You check, you verify whether the claim is based on the abstract. However, you can't really say that everything that is written in some publication is necessarily fact. So basically, the facts change or science progresses and theories get disproven or more generalized theories are found. So yeah, like not everything that is published can be claimed to be fact. So that's why we as well call the project Verif-ai, and why I call this kind of like a verification. And yeah, like we basically use SciFact dataset for this, and that is basically the dataset of claims and abstracts that were based on produced by or open sourced by Alan AI. And it has basically three classes that like there is a contradiction, that the claim is in contradiction with the abstract, it is supported by the abstract, and there is no evidence in the abstract for the given claim. So basically it is a classification task, and yeah, like basically it is either natural language inference or entailment task, and for that we use we fine-tune either the Berta or Roberta large models. So as well, the data set is split in 80-10-10, and yeah, like made to classify into these three classes. The input to the model is as you see below. So we have like class token, we have generated response, we have separator, and then the content of the abstract. And the model is supposed to learn whether the like the second segment is like retrieved document part is supporting or contradicting or has no evidence for the generated claim. So yeah, like now we come to the results. So we tested basically information retrieval with this BioAsk dataset. However, what we kind of learned is that BioAsk dataset is as well a bit biased towards lexical retrieval from the PubMed, even though they claim that it was like manually labeled and manually selected the documents. But yeah, like we got best results with this kind of like hybrid search with rescoring. So like rescoring was done by like first the combination of lexical and semantic was done, and then there was like full non-quantized model kind of like rescoring the results. And yeah, like the best results was made with this like 0.7 for weight for the lexical output and 0.3 for semantic. And then like we did a couple of tests for generative component. However, it was a little bit challenge to think of like how we evaluate it, especially quantitatively. Like one way is to read and then like say, okay, this is kind of like a good answer, this is not a good answer, but we as well like opted out to go and check like how well is referencing going in like different kinds of models. So yeah, like we checked how many references each of the or in kind of like a number of same number of documents, like how many answers are referenced with 0 documents, with 1 document, with 2 documents, 3, and up to 10. So like 10 is maximum because we provided maximum of 10 documents. So GPT-4 Turbo quite often or like the most documents are kind of like based only on a single abstract. while in Mistral 1 and Mistral 2, or like 01 and 02, basically the average is revolving between like 3 and 4, and most answers have between like 3 and 4 references. And then like we did as well like some tests with so quite off, as I said, like these PubMed Q&A data are made of the abstracts that have a question mark. So like this abstract is most probably relevant. So we basically checked whether this whether our information retrieval retrieved the document and passed it to this generative component, and whether this generative component then used this in the answer. So GPT-4 basically missed only one such case where the question was same as the abstract name, while Mistral Lime 1 missed like 29 of those cases, and Mistral version like 0 to 10 of those cases. However, yeah, like you can see in most cases, they are like taking the relevant abstracts. And yeah, basically what we found out that it is really like in 1.2% if we use this Mistral 02, where we may be missing the most relevant abstract. However, we are quite good at like retrieving the good abstract and putting it and basing the answer on it. When it comes to verification, so like this is as well like based on SciFact, and SciFact data set, I have to say, is quite challenging, and even for expert, it's quite hard to see whether some answer is based on the abstract or not. And here with this, like the Berta worked the best. And as you can see, we have like F-score of 0.88 or like 88%. However, with like really generated the normal answers, it is quite much higher because the answers are more kind of like obvious. So yeah, like we as well like build the user interface, and we will be releasing it quite soon to the public, like within the next month or so. So there will be a website, and yeah, like you can visit as well like currently our website, but you don't have this app yet deployed. So yeah, like user interface works that user inputs the questions through UI, question is processed through lexical and semantic search, relevant documents are retrieved, then the generative answer generates the answer. These kind of like documents are split, passed through verification engine, and verified answers are presented to the user through UI with coloring. So yeah, like you can basically log in, you can set up your kind of like weights for lexical and semantic search. You can select as well how many documents you want to pass to the model. It is fine-tuned for 10 documents, but you can provide less or more. With more, it will work to a certain degree, but would kind of like be focused more on this like first top 10, what we learned. And as well, like you can do a bit of filtering around dates and set a bit of creativity to the model. And yeah, like this is basically how it looks. So if you type a question, then in gray, you can see basically the part of the answer that has no references. So it's usually some kind of like introduction or summary sentence. In yellow, the questions is kind of like having no evidence in the paper, and green is supported. And you can as well like hover over the sentence and get more information, like what is the document. You have a link to the document, so you can access it through PubMed. You get as well this kind of like whether it's supported, and you get as well basically based on vector similarity the closest sentence within the abstract. And you can do that basically for all the sentences. So yeah, like for the future, we want to broaden the scope of the project beyond the biomedicine. So we applied for open, like EU's open web search, kind of like a call for third parties. So in case we got to the funding for that, we would go broader to other disciplines and as well like potentially full text. So like we were thinking about like archive or things like that to be included. We will be looking for feedback from the scientific community and basically the users, how to continuously improve it. And yeah, like our aim, as I said, is kind of like foster the trust in generative AI across various scientific domains. And in sciences, it is quite, we believe it's quite useful, especially given that almost every paper would have some kind of like literature review. And as you could see in this user interface, this is exactly what you provide to the user, kind of like condense answer to the given question. So like it can really speed up writing the papers. It could speed up decision making in drug discovery, targeted discovery, and a couple of other applications. And yeah, like as I said at the beginning, this is like collaboration between Bayer and Institute for Artificial Intelligence Research and Development of Serbia. So this is how the teams is looking like. So on the Bayer side, I have like double affiliation. There is like myself, and we have an intern, Lorenzo Casano from Italy, who is working on the projects, and there are like four, like two postdocs and two PhD students from the institute, and one intern doing a bit of outreach for us. And yeah, like here you basically have a bit of more information and like how to get in touch. So like we have already open public repository where you can download the code or look into the code, and as well like we have like profiles on social media, and we have a website. On the website, as I said, we'll soon release the app, and yeah, like that's basically all. I'd like to thank you for the attention, and I'm happy to answer the questions if there are any.
Thank you, Nicola. Now starts the QA part. We have a question here.
Hi, Nicola. Thank you for presentation. I have actually a couple of questions. First of all, why did you use, like, especially you had the fine-tuned Mistral model. So why did you use some BERT-based model for the semantic search, for embedding search? Why didn't you use the embedding produced by LLM?
I mean, LLM would not really produce you embeddings. It is generating you like basically the tokens. And it as well, if you could get like some layer below to get the embeddings, these models are quite slow. So still, I think we had this like advantage of the speed with like much smaller like BERT-based embedding. Like it is, I think the BERT is still in like maybe 100 to 200 million parameters, while yeah, like you have 7 billion with LLM, and yeah, like basically it is kind of like performance, and you really need fast search.
And my second question is, like, how does your model detects if there are no data, when it doesn't know what to answer, and just by kind of setting some threshold for semantic search, and the second thing is like, how it behaves in this situation. Did you consider this case or do something? And in general, if it appears in the, on practice?
Yes, it appears in practice. So you would pretty much get always 10 documents that are closest related to the question. However, they still may not contain any kind of answer to your particular question. And the model was fine-tuned in a way that to say basically, I don't see the answer in this in the provided abstract. Like there is no like yeah, I don't know how it usually phrases exactly, but basically the answer is kind of like provided documents do not provide the answer to the given question. So it would not answer.
Okay, got it. Thank you very much for the answering questions.
Okay, we have another question over there. Gentlemen.
Yeah, so first off, really like the talk. One of the things I was curious about is given what you're optimizing for, you're not, or you're trying to minimize incorrect responses. That's way more important than, optimizing for the perfect correct response, it seems like. And so I was curious with the fine tuning step that you're doing. I had two curiosities. One was if you guys had experimented with creating your own custom loss function, since if I understood the flow correctly, the verification engine happens with your generated response, but it doesn't happen in your actual, semantic and lexical search. So did you guys create or like experiment or research some custom loss functions for your specific use case?
So I believe to be honest, given that I was not doing that part, I am not 100% sure, but like I think we use like rescaled loss for fine-tuning LLM, and that kind of like helps in certain cases compared to like other like kind of like more standard losses. But to be honest, I would have to look up why is that and what was the argument, given that this was done like a few months ago, and I don't really remember anymore.
Not a problem at all. I mean, it seems like a huge project, understandable. The other thing I was curious about is, and kind of in the same place, so maybe also not the right question here, but I was also curious about the way that you structured the fine tuning and prepared the data. So specifically, like if you used some sort of a triplet loss structure for fine tuning your models, then it seems like there would be a big challenge given the nature of your data of providing this is a correct case and this is an incorrect case. Is that the structure that you used? And do you know if there are any interesting insights into how you prepared the data for that?
I mean, the data were so like for generative model, like we provided basically a bit of instruction. Like I think I had it on one of the slides. Like this was the instruction, like in the like answer the question using relevant abstracts, like up to 300 words and reference it, and then given the like we provided the list of 10 abstracts with like ID and then like title and the content of the abstracts. And then at the end was provided a question. So that was just kind of like given to the LLM as a context. Yeah, like basically we use this like rescaled loss and then like parameters that I had on the slides for Coolora and build this adapter. For validation, there was basically there was like a class token, there was a claim, there was separator token, and then there was like abstract, and it ended with the separator token. Here the problem was a little bit that sometimes abstract could be longer than the context. And then I think we still didn't do it, but we're thinking about doing it to kind of like chunk the documents somehow. But it is as well kind of like a question what we do with the training, what we do with the inference, and yeah, like how to kind of like merge it together. But yeah, like we didn't really still experimented with that. Just we know that we have a problem that like sometimes the end of abstract gets cut off.
All right, thank you for the answers, and I'm excited to take a look at the code.
The next up is Dijana Oreški, who works as an associate professor at the University of Zagreb, Faculty of Organization and Informatics in Croatia, where she teaches courses related to artificial intelligence and machine learning. She is the head of the Laboratory for Data Mining and Intelligence Systems, acronym is LUIS. Dijana authored more than 100 scientific and professional papers on the topics of machine learning applications in education and business. Her talk is Retrieval of Augmented Generation in Large Language Models, applying low-code approach in educational setting. Retrieval Augmented Generation, or RAG, has emerged as one of the best paradigms for enabling LLMs to access domain-specific data and as a mechanism for mitigating against hallucinations. Throughout this talk, we'll explore the underlying mechanisms of RAG, shedding light on how LLMs leverage repositories of pre-existing knowledge to enhance the quality and relevance of generated responses. Dijana, stage is yours.
Hello, greetings to everyone. It is my great pleasure to be here in this beautiful city to present the talk entitled Retrieval Augmented Generation in Large Language Models, Applying Low-Code Approach in Educational Setting. In the introduction, I would just give a brief info about my background just in order to justify the selection of this topic. I obtained my master's in computer science and my PhD in data science, both at University of Zagreb, Faculty of Organization and Informatics. Our faculty is a little bit specific because we are somewhere in between social and technical sciences. So, by categorization, we are part of social sciences. However, we do a lot of technical parts, and we have students of informatics and economics. That's why we are using a lot of low code for that students with a little of technical knowledge. I'm proud to say that I'm head of a laboratory for data mining and intelligence systems, which consists of scientists with background in machine learning, but also in business and education. And we, through the laboratory, we are doing projects, mostly scientific projects, which are related to application of artificial intelligence in social sciences. Here is a brief agenda of today's talk, which is basically divided into 4 keywords. In the introduction, just a little bit about large language models and retrieval augmented generation. However, we heard a lot the same sentences, I would say, in the previous talk, so I would try not to repeat that. The focus is on the solving some of the educational problems by combining large language models and retrieval augmented generation by using low-code approach, and I will try to focus on that part of the implementation of AI-based chatbot for our university purposes. I believe that we will all agree that we can divide perception of artificial intelligence before and after 30th November of 2022, when ChatGPT was publicly born and social perception was changed. I believe that a boom of generative AI happened then and now because a lot of things came into the place. On the one hand, there are huge amounts of data available. On the other hand, there are computational resources which could handle that kind of data, and at the end we have powerful machine learning algorithms which can analyze and use that data. And at least, and maybe the most important, there are a lot of investments from the industry and a lot of media coverage which also happened. How popular are generative AI tools, and especially the most famous one, ChatGPT? We can see in this picture, only 5 days. In only 5 days, ChatGPT achieved 1 million users. When, just for the comparison, to achieve 1 million users for Netflix, there was need also, almost 500 days, and for Facebook, 120 days. So today, when we are talking about AI, I believe that we primarily talk about generative AI. So that is something that is actual today, and applications such ChatGPT and others. The past was narrow AI, and which we can see today in Netflix recommendation, spam detection, and so on. And actually, probably the future is artificial general intelligence. Generative AI is technology of artificial intelligence which creates new content, and it is based on large language models, which are based on machine learning algorithms, and their aim is to predict next word in the sentence. ChatGPT is one of the interfaces of large language models. If we want to create some kind of categorization, then at the beginning is artificial intelligence, machine learning, deep learning, generative AI, and then large language models. We saw definitions of large language models, so I don't need to repeat that. Here is one example. So idea is to predict a probability distribution of the next word. Large language models are revolutionized the way that we live, and we can see here headlines from the mainstream media about that topic is ChatGPT start of revolution, and so on. That is based on the benefits which ChatGPT and large language models offer. Some of them are listed here. What large language models can do. They can solve natural language processing tasks using just instructions and a few examples. They can perform math and logical reasoning. They achieve human level on standardized tests. And some of the common applications today are enlisted here. I believe that we all use them for that. Create writing, text summarization, translation, reading, writing, fixing code. I have pointed out one of the definitions which I like a lot. It's not mine, it's from John Mitchell, Stanford University professor, which says that large language models are traditional natural language applications on steroids. However, there are on the other hand disadvantages and the problems. We heard earlier that large language models hallucinate, they make mistakes, and we need to find a way to deal with that. So they, besides hallucinations, they are black boxes. So the question is, how can we explain or interpret their results? So what we need tools to make large language models more reliable. Some of the approaches are fine-tuning of the models and retrieval augmented generation. Here are definitions just to see what are the differences between those two approaches. When applying fine-tuning of large language models, we are performing process of retraining a large language model on custom data set, and that requires high computing power because we need to fine-tune it when new data comes in. Another approach is retrieval augmented generation, which is process of retrieving information from external knowledge sources with the help of a large language model. A few words and background about idea of retrieval augmented generation. So if we want to create AI applications that can process private data or information, or we want to use data that is newer by newer, I mean that it's known after the model's training period, then augmented the model's knowledge with relevant information is necessary, and that's why retrieval augmented generation is here and it's applied. Idea is to incorporate additional data in using large language models. There are 3 keywords which emphasize what RAG are doing. So we want to retrieve the most relevant information, we want to augment query with the context, and we want to generate response. A brief structure is presented here. So 3 parts divided by different colors. Retrieve the first part, augmentation the second part, and generation at the end to generate the output as the third part. So there are 3 phases, and each with their own purpose. The idea of retrieval phase is the following. So the model searches through database or documents to identify what are the most relevant facts to the given user question, to the prompt that user gave. Neću se dobro? U redu je? Sorry. So the second phase is augmented phase, where extra knowledge are appended to the original user input, augmenting the context. And the last part is generation, where large language models analyzes prompt to produce a response. Here are 5 key components of each RAG. Those are language model, vector store, retriever, embedder, and indexer. The foundation of architecture are, of course, large language models. Here are listed some of them. Central to the retrieval function and the retrieval part of the system is a vector store database, which stores document embeddings to perform similarity search. Then model utilizes the vector store to locate the documents and passage that arguments to the prompt. Following to populate the vector store, embedder encodes source documents into vector representation that retriever can consume, and at the end, robust pipelines are preprocessing source documents, breaking them into the passages for embeddings and for doing efficient lookup. So by using those components, we want to empower large language models to use our knowledge, our domain data. At our faculty, we have identified various, I would say, not maybe problems, but challenges, which we saw that can be solved by using large language models with a retrieval augmented generation approach. Here are enlisted some of them. We want to automate administrative support. We want to enhance research support. We want to personalize learning and tutoring, and so on. Currently, we are focused on the first and the second one to perform automated administrative support and to perform student support. There are lots of questions which are on the daily basis. Students send mails to students to Weisdin for students. So by using this approach, we want to automate that, and actually we want to reduce administrative burden on our staff. So the focus of implementation of low-code approach for large language models and retrieval augmented generation was to solve that problem. In order to do so, we have tested and compare different low-code approaches, which is available today, and new applications and new solutions really arrive each day, I could say. At the end, we have decided to use Flowwise AI, which is an open source no-code platform. It has several advantages. The main aim of this tool is to make AI accessible with the users which do not have a lot of technical knowledge, of course. And of course, that approach does not requires the need for extensive coding skills. Key features of Flowways AI are presented here. That is drag and drop interface, pre-built components, integration capabilities, AI model training and deployment, and analytics and monitoring. When we start to use that, it is important to know that each agent or each chatbot consists of the nodes. Here you can see the group of the nodes, each with their own aims. Each flow in Flowwise AI needs to consist of at least one chain or at least one agent. We started with the document loader as a chain which loads the documents, which can be in different formats. Flowwise AI support a wide range of documents which can be used for in our pilot to develop a prototype of AI-based chatbot. We have used a PDF loader, which you can see here. The input for that is text splitter. So we need to then create node, which is called a text splitter, which splits documents into or text into small chunks. We have used recursive character text splitter, which receives two inputs. We need to define a chunk size and chunk overlap. Next, we have used the following chain, which is vector store, which stores text vectors from text. And for that purpose, we have used in-memory vector store. As you can see on the slide, it uses embeddings. So embeddings are the next chain that we used here. So idea is to split text into vectors so that we can perform similarity search, so that we can find the most similar text. And for that we have used OpenAI embeddings using OpenAI model. Chain is obligatory. Chain is the heart of each AI-based chatbot. Here we have used conversational retrieval QI chain because this retrieval chain enables us to use context. So it supports previous questions, and it offers us reference to the previous questions and answers, so that it is very important to have the context. And at the end, we used a model to interact with the bot, and for that we have used OpenAI model. Here is the final structure of our bot. We started with the initial small set of frequently asked questions of the students for only one functionality, and that was the part with student offices. Now we are actually try to fill out with more data to include more functions, such as accounting function, library function, which also interacts a lot with our students, to have, I would say, a big picture and complete picture what is needed for purposes of our faculty, and we believe that that will be over till the beginning of the next academic year. So to conclude, here I try to emphasize advantages of low-code approach in application of large language models and retrieval augmented generation approach, which can be used for those with low technical knowledge and low coding skills. Thank you very much for your attention.
We can start the QA session. If anyone has any questions. There's a gentleman over there.
Hi, thank you for the presentation. Two questions. Do you have experience with loading more complex documents such as spreadsheets and so on? And also we use Flowise for like testing MVP development and so on. And if you have any experience with using their API and custom front ends, maybe some of them.
For the second part of the question, no. We don't have, for the first part, yes. First, initially we started with CSV files, but we had lots of problems with that. So we switched to the PDFs. We didn't manage to get the results with the CSV, so we switched to the PDF. Yeah.
Same, but
what are your experiences?
Yeah, we're loading like large PDFs that have spreadsheets that aren't standardized. So we are looking at how to chunk that and like organize all of that. So that's some of the problems we're researching how to solve.
Yeah, so when you got the solution, you should let us know. Thank you.
Okay, any more questions? There's a gentleman, there's two gentlemen.
Yeah, thank you for the presentation. I find this use case is like really interesting.
Thank you.
My question is like, could you please elaborate a bit on the organizational side of things? Because I find it like how the university as an institution is willing to apply things like ChatGPT in its processes and so on. So how maybe does it work?
Yeah, I can say at the level of the faculty, since we are a big university, the biggest in Croatia, but we have our autonomy at the faculty. One of our strategic goals is implementation of artificial intelligence. So in order to do so, we created lots of documents, strategy for implementation of artificial intelligence, guidelines for the students, how to use artificial intelligence. And here we really enhance them to use that. But however, we want them to be we are enhancing AI literacy. So we have lots of workshops in order for students and for teachers. And we want to learn them how to use it ethically and responsible. That's on the one side. On the other side, we have started with the programs which are related to artificial intelligence. So this year is the first year that we started with the study program entitled Application of Artificial Intelligence in Business. I think that we were first faculty at the university. Our university consists of 30 faculties which employed AI strategy and guidelines for the students how to use AI. At the level of the university, we still do not have that.
Thank you. Thanks a lot. Good luck with that.
Thank you.
Hello. Thank you for the presentation. There are multiple components here that are obviously commercial, and the Flowise itself is also a commercial product. So I was wondering, applied at the scale at the university level, did you do any cost analysis, how much that would cost, and if it wouldn't be like too much at any point in time?
Yeah, that's a good question, and our dean for the finance also asked that question. That's actually work in progress. We are still not out, so I think that one of the criteria on which level we will use it and how it will be, of course, that one. Yeah, we are taking that into consideration, but I do not have the numbers right now, so I can't answer that in terms of some certain numbers.
I don't see any more questions. Thank you, Diana.
Thank you.
Okay, next up is Laszlo Samu. The next presentation is by Laszlo Samu from Material Exchange. Laszlo has a master's degree in marketing and has managed in IT projects for more than 15 years. While working within IT companies, Laszlo has managed software development, IoT, and AI-powered projects from the USA to the Middle East. Laszlo is currently the head of delivery management at Material Exchange. In this talk, we will hear how AI is revolutionizing the textile industry. With the recent launch of AI, the possibilities for its use within fashion sourcing skyrocketed. So, Material Exchange developed the world's first AI sourcing assistant for fashion, Frank the Bear. Laszlo.
Hello. Hello, everyone. I'm Laszlo. I'm a local guy. So from Subotica, I'm representing Material Exchange as said, head of delivery management. I was part of this amazing project and an ongoing process that we are in Material Exchange developing in a very interesting industry, which is the industry of textile and the fashion. I think I just need the thing to move my slides. That would help, thanks. So yeah, what I will talk today, my presentation is not a very technical one. I'm not coming with a technical background, so I will focus more on the business side and the product. But one thing that I will talk about is the textile industry. This is kind of a necessary to understand how complex and challenging it is to apply the AI in this industry. I will talk about how Material Exchange is doing this, what is our role in this huge industry. I will introduce Frank, our AI assistant, who is very scalable and helping different teams and on different sides of this industry. I will show you some images and videos, how it looks like in real life, and I will briefly talk about what's under the hub or the technical side. So I will ask you to tell me what are the 3 words that is coming to your mind when you think about fashion or textile. Sorry? Usually this is, I will help you, this is like new, fashionable, brandy, trendy, shiny, right? These images are actually something that you will see around. This is, by the way, AI generated stuff, but are real ones. We were working with these guys who were developing these. But this is really shiny and nice, but when you move the curtain, actually, this is a completely different story. The sourcing industry is completely different. This is a very, very analog process. This is something that's not really changing in the decades. So if you think about how the garment was produced like 15 years ago, not too many things have changed. It's hugely inefficient, non-transparent, and unsustainable. So when you talk about brands and different businesses, they are barely understanding what's the story behind the materials. And the sales rep, who are actually doing a lot of here and there in this big equation, are spending, you cannot believe the resources in time, money, and etc. to make this whole thing happen and that you are able to wear your garment. So how Material Exchange is actually helping the whole industry is to make it, the whole sourcing process more efficient, transparent, and sustainable. This is not an easy job. This is something that we are working for years, and this is something that is truly needed, especially in the times that we are currently. So I will show you this. I'm not sure, do you see the world map behind, but should be there. For some reason it's missing, but you can. No, that's not. Okay, should be there. I see it there, but okay, it's gray. So, but you can see from the U.S. to China, there are different companies, different type of companies like fabric supplier, garment suppliers, service supplier, manufacturer. These are just the companies that we, as Material Exchange, are working with. So this is multiply this by 100 if we take the whole fashion industry. So where material changes is coming into place, and this is important to mention before I move to the AI part, because the AI is just on top of the existing platform that we are providing. What is very interesting is that, as I said, the whole sourcing industry is really non-transparent. It is working as in a very old-fashioned way. Actually, I brought something that I want to show you. These are the hangers or the material fragments or samples that are actually traveling around the world, from China, Pakistan, or India, or doesn't matter from where, to the brands sitting somewhere in New York office or wherever. So you can imagine the amount of this stuff has to be produced, travel around the world, and reach the brands just to say, nah, this is not something that we want. And this is just one piece of fabric. These are the same stuff, basically just in different colors. And these stuff are moving around the world, and these are producing tons and tons of materials and waste that is actually not used later on. I have one quick quiz question, and I will have a small giveaway at the end of my speech. So my question is like a fun fact thing. I just wonder, can you imagine how many liters are needed to produce this pair of jeans? Do we have any clue, like in ranges or something? Who will be the closest one? I will give you to that person something at the end. 200 liters. 120. Okay, 200, 120. Anything? Sorry? 20. It's much more. Think about hundreds, not. Nobody? 500. Okay. So the answer is 7,600 liters. From the production of the cotton to the very dangerous and last steps in the process of washing and so on. So I will just need to remember who was the... Can you just raise your hand? Who said the... Okay. That's my neighbor, actually. So but we didn't talk. Yeah, so just going back to this. So as I said, there's a lot of non-digital stuff moving around the world in this industry. And how material exchange is actually jumping here to help to reduce the waste, to make it more sustainable, is our one platform called Digital Sourcing Platform. It's based on 3 applications. We have a supplier application, sales application, and the brand application. So my next slide, I will show you these players in this industry, but actually we are targeting everyone. And why this is important? Because this is a service that all those stuff that I showed you is making digital. So the digital and every process that is happening in between the suppliers and the brands when they decide what they want to produce that you will be able to wear the next season is actually digital. So yes, there is the last step to see it and to touch it, because that's the industry. You cannot decide, like, do you want something? The designers need to feel it. But you will not send 200 pieces, but you will send only those 5 that has been, narrowed down. This is the oversimplified sourcing process, and as I said, the whole industry is almost as rudimentary as my visualization here. But yeah, these are the 3 key players, and where material exchange is helping and where AI is jumping in is actually in the middle. These are the agents and the brands. These 2 players in the whole equation is I would say the easiest to onboard into this AI journey, because the suppliers and the production of the fabric is really, really, really hard to move. So we need to do step by step. Moving to AI is really a huge gap in between the analog and the digital process. So what the agents are doing and why we are actually targeting the agents, because suppliers and brands are barely talking to each other. So there is someone, some Joe or some Laszlo or I don't know, Miroslav, who is in between these two, and they are working really well. But these guys in the middle have a hell of a job to do, you know, here and there to okay, visit, bring the stuff, ask, check with the supplier, go back. So digitalization is really needed and is amazing. These guys are really amazed with already what we have, but now I will show you the application of AI, how it's making even more difference. So when you have the digital representation of the garments and the textile or the fabric, it's much easier. So you have it visually and the data backed up. So you can approach easily brand and talk about the business. How the requirements are captured or the data, you can imagine this process like the agent goes to the brand and they have 30 minutes to show and tell what they have. And this is affecting the business for the next 8 months. So these 30 minutes is crucial. How you are capturing the requirements, how quickly you are able to respond to the real-time changing requirements and processes is crucial. So this is where actually Frank, our sourcing agent, is jumping in, and it's like a right hand of the agent doing real-time stuff. One of the things that is happening is the effortless data digitization. So in order to have the material digitally, that's a long process. It's doable. Sometimes it's painful, but it's manageable. But when somebody is, you know, showing you, I want this material or this fabric, they're able to, by capturing it with their phone, they're able to create that material into the system and to move with it and to start gathering data and link it with the requirements. For example, they're able to do the business card. For example, I'm meeting somebody. I just do, you know, the scanning with my phone, and it is added to Frank. From there on, this is already creating some kind of a lead. And during the meetings, when you are adding some, you know, insights and some notes, actually Frank is taking it, analyzing, and it is creating in real time, you know, some conclusions and some actionable items. What else? Create to-do lists, as I mentioned, set reminders, and generate reports. So agents are able, in the same meeting when they are talking to the brand, to ask Frank, like, I cannot remember, what was the last time when we met, and what was the request that they have. So I can like a cheat sheet check that, and, you know, and respond in real time. Also, I'm able to ask him, like it would be the same like I'm phoning my assistant somewhere in the other time zone and asking for, do we have that, or what is our availability of a given request for the garment. Financial data analysis in the fingertips and leverage platform business features. So as I mentioned, we have this platform, so they are able to, from that moment, for example, to, okay, this is the summary, let's send it to the supplier at the same time and set a reminder to the brands in the same process. This is how it looks like. This is our almost daily changing interface. So it looks like a kind of a ChatGPT, but it's much more. And these are the key features, as I mentioned, to create notes, written or voice. It works with both. You are able to scan your handwritten notes, and it is getting into its knowledge base. It is able to create summaries, and I will start showing some examples. Like this is the adding the business card of the person you are meeting, and you are adding some notes, so it is deriving and creating some actionable items with the reminders and some deadlines. This is like the list of the to-do, where you see what was the event, when it's happened, and what are the notes. And this is that part when you are actually talking to it, like with the usual ChatGPT. And this is the summary, for example, that you are able to, for example, tell him, okay, this is the summary, share this with my supplier. So he knows who the supplier for that material is. He knows who am I speaking to currently at the brand side, and it is sending to both. So how the informations are stored, gathered, and exchanged is really on a easy way. Okay, so these were the salespeople. But what about brands? I said that we are covering both, not just the middlemen as the agents, but the brands as well. So this is how the brands are seeing the digital materials. They have a library that they can search, they can filter, they can check some attributes and decide or make decisions for the next season, for example. But this is a bit, offline. This is not really an interactive process because you kind of rely on what your agents are sending to you. And here comes Frank, the bear, who is actually your sourcing assistant from the brand side as well, helping you to reach out and to make better decisions. I will show you, if it will start, how it looks like. This was created for the Amsterdam show 1 month ago. It was defined and was meant to be on a kiosk mode, so it was limited in terms of chatting with it. But we had some pre-made options that with a touch screen, visitors of brands were able to check. As you see, this is Ask Frank. These are prompts that we pre-made. So our big library of materials with these predefined prompts, they were able to check, and Frank responded. Okay, there's no voice. But he's actually even speaking. So by that you were able to check the materials. He was narrowing down the whole library, and you had the feeling like you are interacting. Of course, this is a gimmicky thing. This is not something that you as a brand will use daily, but it was a representation of possibilities. So Frank was kind of alive. How Frank is transforming the brand sourcing. As I said, textual and prompt-based searches. So brands are now able to describe what they need. They are not relying on what the agent thinks that they need. So they are able to move one step toward the agents and suppliers and to define what they actually need with the keywords, phrases. So Frank is actually checking and matching the library with their needs. Image recognition search, this is something that is really amazing, and we have very good feedback from the brands because they are uploading their images or sketches or whatever they are planning for the next season, and Frank is actually recognizing and suggesting all the fabric that is in the library so they can easily find what actually they need. Conversational material exploration, you are able to talk with it. And you are able to actually, when you find something that is interesting for you, you can order a sample and it is getting delivered to you in 48 hours. This is how it looks like. This is also one of the UIs that are changing daily and weekly. We are adapting it based on feedback. And this is the last thing that I will show you in this regard. This was presented in Dubai last year on one of the biggest tech shows there, where we used some visual AIs, and this is maybe more appealing to everyone because this is a consumer side, and I will show you how it was recognizing your clothes, and based on what part of the garment you selected, it was able to recognize and to suggest from the vast library of garments. So it was searching now the library, it was analyzing. First of all, it captured, okay, this is the garment that you selected, so it identified and analyzed it. So these was the responses and the suggestion, okay, these are the garment that we have. And actually it showed not just the attributes of the garment, but it showed where you can actually buy it during the shopping mall. So the use case was here that this is something in the shopping mall where you just go there and you check something. Okay, I'm interested in that. Where can I find it? What's interesting in this use case that everything that you see was generated by AI. So the text, the floor plan, the names of the imaginary brands, their logos, everything was created by AI. So we put it together like a full AI experience. This is my colleague, by the way. And the part that you were most probably waiting for, which I'm not really into because I'm not working in that field, but you will most probably, you are already familiar with these models and frameworks. Our technical team is using GPT family 3.5, 4, and 4 Vision. 4 Vision is used for this visual analysis, image analysis, extracting information from fabric samples and business cards. LangChain is used to streamline the development of and orchestration of our AI applications. This is like the easy way to combine all these different frameworks. For fine-tuning, our team is using, and the prompt engineering techniques are used, the zero-shot and few-shot learning. Also the React to break down the complex tasks into smaller manageable steps. So this is how we are moving step by step. And the chain of thought prompting, we encourage models to generate intermediate reasoning steps before arrival at the final answer, improving transparency and explainability of the AI's decision-making process. Also regarding the data knowledge part, these are the methods that our team is using. So Elasticsearch as the knowledge base. This is recently introduced. Elasticsearch is our primary data store, so functioning as a comprehensive knowledge base for Frank. And we also have the Retrieval Augmented Generation, or the RAG, powerful technique that combines information retrieval with language generation. So yeah, I cannot talk very deeply or in details about this. Most probably you know more about them than me. But I just wanted to show you how a company from Subotica, actually we are a Swedish company, but our headquarters is in Subotica. We have offices from New York to China, are actually trying, and I think we are doing very good job making impact in this industry that is actually becoming more and more with the sustainability and every other aspects. So thank you for your attention.
Thank you, Laszlo. If anyone has any questions, the QA can start now. There is one question over there from the lady.
1, 2, 3. Okay. How widely are these tools used? Do you have you managed to sell it to somebody? Who uses this at the moment?
Yeah, very good question. So our network of agencies, so Material Exchange has, I think, 5 different agencies from New York to China. So this is tested and used by our internal network currently. So our business model is not moved yet to make it available to third parties. So because I think it was mentioned at the very beginning of the conference that these small teams and SMEs and the small teams are a bit skeptical. So we want to crack that part first, so the agents are confident in using it and to rely on it and to improve their businesses. So this is, I would say, self-contained in that our network of agencies and agents.
Well, it is expected actually because this is new.
Yes.
And the other question is technical. Do you know what database were you using before Elasticsearch? You said it's implemented.
Yeah, recently. No, I'm not sure. So we have all these databases. MySQL, I think, or something that were used for the materials. But
Postgres, maybe.
Postgres, yes, exactly.
MySQL.
Postgres.
Okay,
yes.
okay. Thank you very much.
Okay, there's two questions.
Do you have any data about here? Yes. And you said you're using it internally, but from your agents. Do you have any data? Did it speed up any process, any metrics to evaluate the effectiveness of the product?
Very good question. Actually, we are in the middle of that. What we are seeing, because in our platform we have the so-called leads hub, so everything that is tracked through Frank is actually ending up there. So we have a very good overview what's happened and the performance of agents. We are even now, it became so transparent, like the difference in between how agents work and their effectiveness. So I'm not saying or mentioning just the financial part, but everything in between. Because in this industry, that's very interesting that from the first visit to the brand of the agent, when they see the money from it, is like 8 to 10 months. So it's very important at the early stages to know how they are performing and what they should do, because the end result of that visit can be seen very, very late. So yeah, to answer the question, we are working on it to have a proper data behind. Yeah, so the answer was processes that took usually 2 weeks is now reduced to 2 days, which is, I think, impressive. Okay.
Thanks a lot. Thanks a lot, Laszlo, for the presentation. Very interesting use case, and also, yeah, the presentation is beautiful. I wanted to ask you, I'm actually amazed by the database that is used here. So I imagine it's like a lot of data, and I am thinking, like, what is the history behind this? So did you start collecting the database, and like the Frank AI is just a top of the iceberg, or was it all made just for the AI purpose, for the purpose of this assistant?
No, actually, very good question. So AI came as on top of it. So we were doing this business for years now. So a lot of processes were still analog or click-based or I would say conventional way. So we had the data, but now what data we are actually seeing through Frank is also amazing. So it is just adding up.
And another question here, do you think this is scalable to another industries? So for example, we're speaking about textile. What about, I don't know, like food industry,
No,
I don't know, like chocolate production?
Yeah, absolutely. Like absolutely. This is scalable, and that's the thing that how this, as we are seeing the progress in this industry, how it's skyrocketing the agents in their daily work, this is absolutely applicable to any other industry. And I would say maybe it would be much easier to crack those industries than this industry, because this is so analog that it's like, you know, you need to fill the gap, which is real big. Thanks.
Okay, we have time for one more question from the gentleman.
One more question. Frank is good, frankly speaking. So yeah, question from here. Right now, Frank can transfer, visualize the color, right? A bit of texture, but it lacks information about the behavior of fabric in the final product, like how thin or thick, how soft the fabric, right? What is like physics of the fabric when you, I don't know, put it on the body? So do you have some solution or plan to improve like Frank in this direction? Maybe like a simulation of the physics of fabrics or anything like this?
Yeah, that's a very good question. So far, where Frank is good at is some degree of understanding or recognizing, but of course this is part of the machine learning process to teach it, okay, like this is 30% right, but the rest is not. Where Frank is good at, because behind those fabrics, we have, you cannot imagine the amount of attributes for that. So it doesn't mean anything to you or me, but the industry on the other side, the designers, are asking, like, is it 2% before or after wash, stretch here or there? It means a lot to them. So this is where it still takes time, you know, to teach the AI to make this difference. Visually, it's not easy, I would say, but from the data perspective, it is giving very good results. Thanks.
Thank you, Laszlo.
Thanks.
I saw.
Yeah, and I promised to give away a small franc to my neighbor. Actually, it turns out it's my neighbor, but let me.
Also, I saw there was a lot more questions for Laszlo after there was a lunch break soon, so you can ask questions to Laszlo later. Okay, next up is Arseniy Shkunkov. Our next speaker is Arseniy Shkunkov, and he is a machine learning engineer specializing in natural language processing at ABBY. He will talk about efficient language model inference. Transformer-based language models are widely used for the natural language processing tasks. Although they are powerful, more resources are required to train and use them. The extremely high inference cost in both memory and time is a bottleneck for using such models for real-world tasks. The talk will cover different methods for memory and time-efficient inference, how to get the most out of model training, and memory time accuracy trade-off. Thank you. Where's Arseniy?
I'm here. Hello, everyone. I'm quite pleased to see all of you here. There's really a lot of you. And so, yes, my name is Arseniy, and I'm a machine learning engineer at ABBY, developing NLP technologies for our document processing platform. And today my topic would mostly be dedicated to inference. And while I was preparing for the talk, at some point I stopped and thought why I'm interested in talking about this. And quickly I got an insight, because when I started my career in the summer of 2021 at ABBY, only 1 or 2 years had passed since BERT model and GPT of the first generation were released. And at that moment, industry already understood and started to adapt to this, integrate into products and everything else. But I really don't remember a lot of discussions about speeding models up, and mostly people were focused on developing solutions for question answering, summarization, and other different problems. And also there were a lot of talks about how we could achieve greater capabilities for that models. There were many approaches, but for example, OpenAI at some point decided and said, okay, just stack more layers and put more data into your pre-training stage. And what we can see at this slide is a timeline of language models development. So we can clearly see that starting from 2020, when BERT and GPT were released, there is a clear trend on getting the models bigger, bigger, and bigger. And that's what, from one side, gave us a lot of new capabilities and approaches to solve different tasks. But that also comes with a price of the size of a model. And when we talk about model size, we usually talk about the number of parameters in these models. And there's a question, what does the model size affect actually? The first thing that comes to your mind when you see the model, okay, look, cool, it's 70 billion parameters model, but does it fit my GPU? And doing some simple calculations, we can find the following thing. Suppose we would like to store a 1 billion parameters model on our GPU using 32-bit floating point precision numbers, or as we as machine learning engineers refer to this as full precision. We know that one parameter is represented with one number in full precision, that is 32 bits, and it's 4 bytes of memory. If we multiply this by the number of parameters, we will end up with 4 gigabytes of memory. Not a big problem for modern GPUs, but let's look at real examples in half precision. So, for example, GPT-3 has 175 billion of parameters. If we use half precision, then we just multiply this by 2, and we easily end up with 350 gigabytes. The latest Llama of the 3rd generation with 30 billion parameters will require you to have 140 gigabytes and so on. And one of the best GPUs we can get on the market is NVIDIA A100, or there's a newer one, H100, that has 80 gigabytes on board, but it's costly. So the second thing is model speed. And when we're talking about this, usually we're thinking about how quickly we can respond to the user requests. And this process, the model speed, usually defined by generation latency, that consists of a time to generate the first token, and this also includes the time to process the initial input sequence. And then we have to also add the latency to generate the whole sequence. Okay, we have right now two things. The first one is memory, second one is speed. The third one is quality, and usually there is a trade-off. In an ideal world, we would like the model that will work fast, perform well enough, and would be cheap in terms of memory. But in reality, things are a little bit complicated, and you can't have all three things at once. So with that, we're starting to think how to optimize our inference to achieve a normal trade-off for our applications. There are several approaches for that. One is a big class of methods that called by a common word model compression. It includes knowledge distillation when we have a teacher model that teaches a smaller tutor model to match its output probability distribution. Secondly, we have pruning, is the method that allows us to reduce unnecessary connections in our neural networks, and by that speed up our model using modern hardware. And the last one is quantization. So additionally, we have improvements in our layers or attention mechanism designs, and we have software acceleration for our hardware, that is inference engines and serving frameworks. And in my topic today, I would like to highlight these things: quantization, some kind of efficient attention layers, software acceleration, and give quite a general perspective on the research field, because if you, for example, open any survey that discusses quantization, you'll see that there are around 15 or 20 different methods of how to perform quantization, and each method has a separate paper. So let's start with quantization. Quantization is a process when we would like to transfer the weights from of our original model from a higher precision to a lower one. And I guess this picture explains it very clearly. Essentially, we mostly train, at least before 2023, models in float 32-bit precision. That takes 4 bytes of memory. And there's a quite trick that for that, we can use a float 16 or half precision, not losing much in accuracy because of different reasons. And for example, this will allow us to reduce the required memory twice. And also, we can perform our operations, for example, matrix multiplications, faster with lower precision arithmetics. Additionally, we also can quantize our model from float point precision to integer numbers, and that's also an approach. It's also commonly used. But there are some tricks. So, if we look at the specifications of NVIDIA A100 and exactly at a table that explains how different precision format, I mean, at what precision format we can perform, how many operations we can perform. We can see that if we'll use standard 32-bit precision or full one, our through output of operations is 19.5 teraflops. It's a number of floating point operations per second. But if we will switch to a half precision, NVIDIA has optimized its GPU cores to perform around 20 times more operations per second. So the formal definition of the quantization is we have to define a quantization operator that will take our real number or number and a half precision, divide it by some scale factor, round it if we're talking about integer, and then minus 0 point. And we also have to determine a dequantization operator. So the original goal, we have to match our initial weights distribution and scale it to a new range. And this particular example, it's 8-bit integer. But what is scale factor and 0 point? So scaling factor, it determines at what rate we have to compress our weights. And the most popular choice how to do this is to find a clipping range alpha and beta, and then subtract a from b, then divide it by 2 in power of b, where is the number of target bits in your precision, then minus 1. But how do we choose these alpha and beta values? There are two ways of doing this. The first one is called symmetric, where we just take in the maximum between our absolute values and the original distribution. And so it will lead us that the same maximal number in our original distribution will be used as minus from that side and the plus from right side. And then we end up with a 0 point equals 1. So the 0 point is a point in your original distribution that becomes a center of your coordinates that you want to also transfer to your new distribution for a tighter quantization range. And for that, there is a better approach that's called asymmetric quantization, calibration. And that approach, you use, you set your clipping range in the original distribution as the leftmost value in your distribution and the maximal value of this distribution. But then you have to match your initial 0 point to a new one in your distribution. And for that, we can just take commonly used approach, take the leftmost value divided by scale factor, and that will be approximately your new 0 point. Secondly, there are different approaches on how to quantize model. The simplest one is post-training quantization, where we have a trained model and we just want to quantize it to integer 8s, just assuming. And the scheme is the following. You have a pre-trained model. You actually can have or not have calibration data because it's not that important, and you go with a static calibration when you define this scale, factor, and 0 point only by statistics we have discussed above. And then you use it to quantize your model, and voila. The other approach is to train your model and find the theta coefficients for your clipping range during fine-tuning. So that requires additional data, and it costs you, I would say, significantly, because you have to approximately use maybe 10 or 20% of your time spent on pre-training. So summarizing, if we use quantization-aware training, we have to get access to original data or quite enough data set to adjust scale factors. Obviously, it consumes more time because of training, and we have the same amount of computational resources to train it. But it leads to higher accuracy, especially if we go in for a lower precision. And the post-training is quite a simple procedure we can use to get the result right now. And mostly it works well when we go from full precision to a higher precision, not going down to integer and anything else. OK, so that's all with quantization. And here I wanted to show the following thing. When we have a real-time application, usually it interacts with our LLM via some kind of a web server you use for your model. And we can split this, this application in two steps. So for model optimization, we will have inference engine that will perform different optimizations, like also mentioned quantization, graph optimizations, and so on, in order to make our model faster and consuming less GPU memory. And secondly, we could also use a serving framework that will handle, query, and schedule all incoming requests and will allow you to process them more efficiently. So inference engine usually helps you to optimize your neural network by optimizing linear operators with linear operator fusion, suggesting you different options for your attention mechanisms. And there's also a cool thing that's called speculative decoding. It's actually quite a promising field of research right now, and there are maybe already 5 papers I've seen. So the initial problem with generation in decoder-only LLMs that we have to generate our output sequence sequentially. That means that we've generated one token after the prompt, then we feed all the same tokens into our model, get the new token, and so on. And that's quite slow, and we can parallel this. But with speculative decoding, we can do the following thing. We can take a so-called draft model that is usually much smaller than our big model we would like to use for inference. And while our new LLM generates, while our big LLM generates a new token, at this time, draft model can generate up to, I don't know, 4, 5, 6 tokens and suggest them to our main model for verification. And a bigger model in this approach usually verifies the given draft tokens and decide which it wants to accept or which it wants to decline. If it accepts all, it just starting generating new tokens and the process goes itself. Or otherwise, we can say, OK, this is not the option we would like to get, and usually people do not talk like that. So, for example, we accept 2 tokens because we consider them valid, and everything else we will have to regenerate. And different variations of this method allow you up to 4 times speed up for your inference. I've added a link to the survey and compression table in the appendix, so when the slides will be available on my LinkedIn, everyone could look and check it. Second thing is that also commonly used and has in many frameworks like Hugging Face, it's a flash attention. So the problem with original attention, actually one of them, that its implementation uses high bandwidth memory of your GPU. And this memory is perfect for storing your a large amount of data in that memory. But it's very slow with load, write, and computational operation and sorting operations. So that's why authors of the flash attention decided that we can do 2 tricks. The first one, we can chunk queries that we send to attention layer. And secondly, we can, using this chunking, we can reserve some space on a GPU static random access memory, put these chunks there, and while we're finishing the computation, by that time, we can access and transfer queries, keys, wireless from for our next calculations. Second problem with attention, and it's also a problem for decoder-only LLMs, that every time we're calculating a new token with attention, we have to recalculate attention for all tokens in the sequence. And that leads to a problem that we also want to somehow want to mitigate. So we are going to achieve a speed up with KV cache, but at cost of memory. So instead of computing each token in a sequence every time we got a new one, we will cache our key vectors and value vectors in the cache, and we will only multiply these key and value matrices by each new token. So that leads to higher memory requirements for storing all previously cached keys and values, but it comes with a speed up because you do not need to recalculate all the previous token in the sequence. The only small problem with that is there maybe a way to how to allocate memory in a more efficient manner? Because if we go with this, we will have to somehow allocate at once a continuous space of memory on the GPU, and that problem is solved with so-called paged attention, and probably I would better call it paged KV cache. So KV cache allows you to split in chunks in different blocks your key and value vectors, matrices into like block vectors, and put them in a high bandwidth memory, and when you need it, you can take out of there into your RAM memory on the GPU block required for calculating the current sequence. And the last one thing that I wanted to mention is continuous batching, because there are 3 main approaches for this, how to group the requests for your LLM. The first one is like simple static. When you have a request, you process it, finish it, return, and then you accept a new one. Then you have a dynamic batching, when you wait when the full batch of examples will be collected. Only then you send it to your LLM that processes it, returns the result, and so on. And the authors of continuous batching method decided, okay, we still waste compute about that. So if we look at the lower slide, because I actually a little bit messed them, we can see that there's a time scale on the X and sequences on Y scale. And yellow tokens is the input sequence, and blue ones are the generating sequence. So from that picture, we see that we started generating tokens at different times because of sequence length, and we also end up with different time required to generate an output sequence, because it could be a short one or a longer one. And if we look at this picture where red tokens are marked with red, there are 2 time slots left, 3 time slots left, and 1. So that means wasted compute time. And continuous batching solves this problem by dynamically adding next sequences into the batch. That model can process new requests while while it yet not finished with all the previous one. So I guess that's the final slide. There will be a link for the survey, actually, I used for this table, where the authors of the paper decided to check different serving and inference engines with the Llama 2 model of 7 billion parameters, and test how what opportunities it includes and what's the speed of generation. So there's a small table that lists all the popular frameworks such as Tensor, RT, LLM that provides you a lot of capabilities for your model optimization and also serving. And I guess that's it. So there's a time for questions.
One question that I had when you were going over the part about quantization. So I was curious, when you had your 2 different scaling functions there, and definitely they were interesting, but what advantage does that give the model as opposed to just, downcasting, right? So you've got a float of 32 and you downcast it to a float of 16. What is the loss from that you're addressing with the scaling functions you had?
From full precision to half precision, there is no significant loss because of neural networks. Because neural networks are quite robust to precision size of float point in numbers, and they also have techniques like batch or layer normalization that allow you clipping range that allows you to overcome these challenges of switching to half precision. Yep, is it, or you have anything else to add? Maybe I didn't answer correctly.
I may also have been misunderstanding the goal of the scaling functions, but you had symmetric and asymmetric scaling functions.
Ah, yeah, okay.
And so I was curious. So let's say you have a 16 byte number, right? And then a 32, and then you cast it to a 16. This here, if I was understanding correctly, this is just a different approach to doing that, right?
Yeah, but I guess you can simply downcast because the problem is that in the original full precision, there's a small probability actually, but for example, your leftmost range, your leftmost original range doesn't fit into your new range, and that's why you can't simply downcast that, and you have to rescale and find a new left border for in a new range. Mostly that's not super actual for full and half precision because they're floating point numbers. But if you go to integer, so the first thing you don't have that kind of precision after the dot, and you have a really small tighter range from minus 127 to 128, and that's why you need scaling in that case.
All right, yeah, that makes sense. Appreciate it. And then the other thing I was curious about is, we work a lot with really high performance inference as well. Not so much with LLMs, but in other areas of machine learning. And one of our biggest challenges that we put a lot of work into optimizing is actually decreasing memory copies, right? So,
yeah.
So I'm curious, in something like this, now, I have not written my own LLM inference engine, right? But we have written plenty of, embedding inference engines and whatnot. So with this, how are you, particularly in some of your caching stuff, how are you managing, I guess, the trade-off where there's no chance of race conditions or anything, but there's also no memory copies or limited memory copies?
If I understand correctly, you're talking about encoder models, yes? Because you mentioned using embeddings a lot.
Well, yeah, sorry, I was just saying that's some of the focus on our end, but I was curious with what you're doing here, right? So in your inference, has that been a big focus for you, is decreasing memory
Look,
copies?
unfortunately, it wasn't a big focus for me yet, but I think in the upcoming future, I will definitely have to face it.
Yeah. All right, yeah, understood. Thank you.
So welcome back after the lunch. We hope you had a pleasant break, and we are starting our program again. Aleksar Shashansky is a data analyst at SmartOcto with nearly 3 years of experience. In professional career, his focus is on building cloud infrastructures for running various machine learning and AI-powered services in the field of digital media. He will talk about AWS infrastructure behind AI and ML products in digital media. This session will cover up the whole process of building an AI and machine learning applications on Amazon Web Services platform in the field of NLP. It will include understanding of each component that is used to build and maintain such a service, and provide basic overview of business logic behind each service, different approaches of using LLMs, and via AWS Bedrock. So, thank you.
One, two, three. Great. Hello, everyone. My name is Aleksar Shashansky, and I'm data analyst in SmartOcto. Today, I will be talking about AWS infrastructure behind AI and ML products in digital media. Here is the agenda of the presentation on this slide. And my presentation is divided into 3 parts. First, I'll talk about what we do in SmartOcto. And after that, I will go deeper into the technical stuff. And I will start by explaining AWS infrastructure behind AI services, exactly generative AI-powered services. And after that, I will explain AWS infrastructure behind traditional machine learning approach. Okay. Because SmartOcto is taking place in digital media, our AI and ML services have a role of some kind of digital assistant, which we call SmartOcto AI. And primary users of SmartOcto AI are journalists and editors. And after all, all the people from the newsroom can actually use our services. And the data team in SmartOcto last year was heavily focused on developing different AI and ML services, which help those people to create better content, to create more creative headlines, and to publish their articles at specific times so they get the best reach with the minimal effort. And our AI and ML services are divided in 2 categories, AI stack and the ML stack. AI stack is a set of generative-powered AI services which are developed using a RAG framework and rely on LLMs. And my focus on in presentation here on the AI stack will be on AWS Bedrock service. And about machine learning stack, this is a set of traditional machine learning powered services, and the main focus in this application will be on AWS SageMaker service. And besides AWS Bedrock service and AWS SageMaker service, I will cover up all other services that are needed for such an application to run properly. Okay, you can see the diagram of AWS infrastructure of AI stack. I will just go briefly through all services, and later I will go deeper into more details with each service separately. Okay, we can start from the business logic. Business logic is the core of the stack, and it contains all basic functions and things that one AI and ML application should contain. It contains data pre-processing, model handling, error handling, and response building. Okay, so we have business logic. We need the model. The model is provided through AWS Bedrock API. You just create one API call, and you have model you want on your hands. I will go deeper into details later for AWS Bedrock. Now, when you have your business logic application, you have model. You have to tell model how to behave. It is approached by instructions. These instructions are stored in separate TXT files, which we call prompts. Prompts differ from model to model and from service to service, and the prompts are sent with every API request to the AWS Bedrock service. Now, when we have model and prompts that tells the model how to behave, we just need to store training embeddings that are stored in the AWS RDS service, and these embeddings are created externally from this stack. And now we have our business logic locally running. Now you have to provide access to your stack to the clients. And now how is that approached? Firstly, you have to create Docker image just to avoid the familiar "it works on my machine" problem. And then you create a Docker image, and you have to store that image in the cloud. It is approached by using AWS ECR components that represents a Docker image repository. Now you have your Docker image on AWS cloud, so you have to deploy it somehow. This is approached by using AWS ECS service. Concretely, we are using AWS Fargate service and AWS task definition service. In AWS task definition service, you register your Docker image, which is stored in AWS ECR component, and then AWS Fargate service invokes that service, and then it is deployed and running. And now, when we have our service running in the cloud, we have to provide access to the users, so users can get the prediction from the model. And it is in our case, it is approached by using AWS load balancer. Well, application load balancer just provides a DNS name, so users can access that service. But maybe this is not the ideal solution, because maybe the better solution would be to put some API service in front of the user. But we struggled a lot with the time limits. For example, we should put API gateway service, which will go deeper into details later. But it has a small time limit. And because we are using, I forgot to say, we are using in the business logic, we are using Anthropic Claude 2.1. So it often takes a lot of time to generate the answers. For example, it takes 30 seconds, 40 seconds, or 50 seconds, for example. But the timeout of the API gateway is 15 seconds, so it didn't suit for us. So we left application load balancer here that provides the DNS name to the user, and user can access the stack. Now, we can go deeper in each component of the stack. First is AWS relational database. As its name says, it allows users to store their data in relational database on AWS cloud. And it is easy to manage and maintain. And what is important, it provides a wide range of engines that are supported. For example, MySQL, MariaDB, PostgreSQL, which we are using, Oracle, and SQL Server. It has high availability. It is available in all the AWS regions. And it's also easy to scale. It's easy to scale both horizontally and vertically. And in our case, what is helpful when you're building AI and ML application, that PostgreSQL in AWS RDS has new extension that is called pgvector. Pgvector extension is used to store embeddings for machine learning models, and its engine is also optimized for quick semantic search. So it is very helpful to use if you're storing your embeddings from the different models. Okay, let's move on to the AWS Bedrock service. AWS Bedrock service is fully managed service that provides access to various high-performing foundation models for a single API. You just call the API, and you have AWS Bedrock token, and you access the model. Okay, and it's easy way to build any kind of generative AI applications with security, privacy, and responsible API. And also, AWS Bedrock provides wide range of available LLMs like Amazon Titan, Anthropic Claude, Jurassic, Llama, and Mistral. And one more thing about AWS Bedrock service is pricing. It provides two types of pricing. The first one is on demand, and the second one is provision throughput. In on-demand pricing, you pay only for what you use. You have input-output tokens, you calculate how many of them you used, and you pay for them. And it is simple math. And on the other hand, provision output provides 1 to 6 months commitment to the AWS Bedrock, which you can calculate if it's worth it or not. And one more advantage of provision throughput is that you can use custom AI models. And one disadvantage for now for AWS Bedrock is its availability. It is generally available in only 5 regions, AWS regions. It's US East, US West, Tokyo, Europe Paris, and Europe Frankfurt. And you should be aware that if you are accessing AWS Bedrock from the region where it's not generally available, you will have to pay for the data transfer for it. And one more thing about AWS Bedrock is that it can auto-scale your requests. Well, it will not deploy another instance for you, just for you to scale your request, but they say that they make copies in every region, so they scale between these copies of the models. And this auto-scaling differs from the model to model, and it depends which model you're using. Next service is AWS Elastic Container Registry. It's managed container image registry service that is used to store your Docker images. And it supports both private and public repositories where you can store your images. And also, if you're using ECR service, you are able to track the versions of your application because it supports tags with each Docker image version. So it is very easy to track which version is your latest version in the production, for example. And one more important service is ECS service. It's Elastic Container Service. It is fully managed container orchestration service. It allows you easily to deploy, manage, and scale containerized applications. And it contains of two main components. One is ECS task definition, and the second one is ECS cluster. The task definition, in task definition, you register your Docker image that you're stored in ECR service, and it's like some kind of connection with ECR where you stored your image. And the ECS cluster is a group of one or more compute engines. So you have to deploy that Docker image. So you're using ECS cluster. And ECS cluster contains two types of services. One is ECS service, and one is ECS task. When you deploy ECS service, when the service is deployed, it stays permanent, and it is ready in every moment to be pinged by the user and to retrieve the response. On the other hand, ECS tasks invoke service periodically. For example, when you send a request, it will invoke the service, you get your response back, and it will shut down service for some time. And I have to mention that both of these services can be types of Fargate and EC2 instance. AWS Fargate service is like a serverless approach where you don't have to worry about maintaining and scaling your instances. The Amazon does everything for you. But on the other hand, when you deploy ECS cluster with EC2 service, you have to worry about scaling and traffic between your instances. Okay, and the last component for the AI stack is application load balancer. Just to remind you, Elastic Load Balancer automatically distributes incoming traffic across multiple targets, where the application load balancer is specific type of Elastic Load Balancer which works on application level. And it distributes incoming traffic with the round robin technique, but you can always change that technique. And you can also add or remove targets, where targets are, for example, some API addresses or ECS services or EC2 services, whatever. And one big advantage of application load balancer is that supports health checks. Health checks, you need health check just to track if your application is alive or not. You define that health check method in the target of the application load balancer, and also you define it in the business logic of the application. So it can be just a simple HTTP GET method that retrieves 200 response. So you will know it every second if your service is alive or not. Or do you have to do something with it to deploy it again? And also what I said, and it is important for us, is that application load balancer provides domain name with which users can access our stack. Okay, I will just go back on the diagram again when we know more details about every component, just to quickly go over the stack again. Okay, we have business logic. We get model to the business logic from the AWS Bedrock services. We just call its API and it retrieves model for you. We have separately stored instruction and prompts that tells how the model will behave. And our embeddings are stored in vector RDS database. Okay, now we have image locally. We deploy Docker image to the ECR service, ECR registry, and then we register that Docker image to task definition and deploy it using AWS Fargate, and our service is persistent and it's running. And after that, with load balancer, we just provide the DNS name so it can access, so user can access all these services. And it is worth mentioning that load balancer, of course, will have a big role if you, for example, have multiple instances of ECS services, because you can deploy multiple instances of ECS service. Because, for example, if you predict that you will have a lot of traffic for one instance, you have the parameter to set how many maximum instances ECS will deploy. So if there is high traffic on the first instance, ECS service deploys one more instance, and the services will be working fine again. Okay. Let's move on to the machine learning stack. Machine learning stack in my presentation will be divided into three main parts. Just take a look at the bigger image, and I will then separate every part in each slide. So the focus in this ML stack, as I said, is on AWS SageMaker. Okay, we can move on. Okay, we have the first part is the model image training. SageMaker model image training. First, I have to say what is actually SageMaker. SageMaker is AWS service which provides you to build, manage, and train machine learning models in AWS cloud. And we will describe the training job now. You have, for the training job, we need training image. That is Docker image built from the training logic, from the Python script. And of course, we need training data. And then the training job is deployed by using job name, uploaded training data path from S3, instance type which we want to train, on which we want to train model, and number of those instances where we want to train our model. And after that, when training is finished, the trained model are stored in AWS S3 bucket in form of model artifacts. And then it is later used to deploy SageMaker endpoint. Next part is AWS SageMaker endpoint deployment. It consists of two main components. It is model container and it is endpoint configuration. The model container consists of inference image. What is inference image? Inference image is the business core logic of the application. And endpoint configuration is set up later. First, model container needs inference image and trained model path. And the endpoint configuration needs trained model, again, instance type, and again, number of instances. Now, when we have our SageMaker endpoint deployed, we have our application running. We need to provide access to client again, to the user again. First step is Lambda function. Lambda function is invoking that SageMaker endpoint. And it also contains request preprocessing. And when it processes request, it invokes our SageMaker endpoint in order to get the prediction. And now, how users can invoke that Lambda function. Users can invoke that Lambda function using API gateway, which I mentioned earlier. And now it is suitable to use this API gateway because traditional machine learning models takes way less times than LLMs to generate the answer. And now the time limit is, for example, 2 or 3 seconds maximum. And it is very suitable to use API gateway in that case. And in API gateway, we register few HTTP methods, for example, get or post methods, where we can access this Lambda function. And with this slide, I would cover up all the MLOps things that we use in our AI and ML stack. And one more thing, I would probably like to represent our data team that consists from data scientists, data analysts, data engineers, and machine learning engineers. Thank you.
Thank you, Alexa. So now the QA session can begin. Anyone has any questions? There's one question over there.
Thank you for the talk. How does this workflow with AWS services fit to standard CI/CD pipeline? When I, for example, have a new release and I want to roll out like the new model automatically with a new inference code or new processing code, whatever. So how do you have this like two workflows linked together, or it provides something, I don't know, alternative on
yeah, you mean AI stack or ML stack or what? Because there are different applications in
anything.
Well, the user in our case is the front-end application, which is deployed separately than this stack. This stack is deployed via Jenkins jobs. The AI stack is deployed by Jenkins job, and for now, AWS SageMaker architecture is deployed manually. If you meant this.
Okay, let's say something happens during the inference time, and I want to switch to another version of the code and use previous version of the model. How do you manage it?
We manage it that we reverse to the previous version on the Jenkins job. We just release previous working version.
Okay.
If you meant that.
Okay. Yeah, makes sense.
Thank you.
Thank you.
Okay. Any more questions? There's one gentleman over there.
First of all, thank you for the talk. So my question is, since you are using Bedrock as your like LLM provider, did you use any infrastructure for or services in AWS for guardrailing it? Meaning that controlling the outputs for like, I don't know, hateful speech or something like that?
Well, not yet. We're just tracking all the responses in the AWS CloudWatch. That's all for now. But we are still developing it, so maybe in the future we'll develop it.
Okay. I think that's it. Thank you, Alexa. Okay, continuing our sessions, our next speaker is Mikhail Roskov from Iterative AI. Mikhail is a seasoned team lead and solutions engineer with 7+ years of experience in data science, machine learning, and MLOps. He will talk about MLOps for computer vision and generative AI applications, DataOps, and distributed ML. This talk delves into the innovative use of DVC, data version control, and Ray for automating distributed ML pipelines with a specific focus on computer vision and generative AI applications. Mikhail?
Thank you very much. Hello, everyone. Hello, everyone. Okay, yeah, everything works. My name is Mikhail. I'm a solutions ML engineer at Iterative AI. It's a company that develops DVC and other open source tools for machine learning developers. Also, we have the old version of the presentation, but it's fine. I'm author of a couple of courses about MLOps tools, mostly open source, how to stick them together, how to use them for different applications, mostly for batch scoring in computer vision and table data applications like banking, something like that. And also, like in the company, I work with different companies from different industries that uses DVC mixing with other open source tools, Airflow, Ray, I don't know, MLflow, like whatever. So a lot of different solutions that we try to organize somehow and help people to bring good engineering practices into data science and machine learning development. So yeah, today I'm going to talk about like mostly generative AI, but this is how our tools like fit to this area. So DVC is a okay, yeah, okay, thank you. Yeah, it's not a problem, but thank you very much. Yeah, there are a couple of interesting slides that I did. Cool, thank you. Oh yes, I'm also founder of MLOps community. We started that community with the guys like a few years ago just to discuss like new MLOps topics that were very, I don't know, promising and interesting a couple of years ago before the LLM came. Okay, so DVC is our core product. The idea that you need to version data that you use to train your models. Because like if you change the data, so you cannot like, and you change the data and you try to compare like different models, you cannot understand why one model behave like in a different way or which one model is better. So you need to understand the different configurations, hyperparameters that you used, and also like you need to understand what how data is changed before the between experiments. And this is how DVC helps. It links versions about data versions and code versions using Git, and using like Git, you can like actually control what version of code and data used together in your machine learning experiments. This is how it works. And on top of this open source tool, we built a studio that the tool for collaboration. And now we are working on a new tool. It's called DVCX, and this is a specific tool for data management for unstructured data. I have some problems with the clicker. Yeah. This tool helps to manage data and metadata, like labels and annotations for your data in an efficient way. For example, for generative AI, for three main cases: text, computer vision, and multimodal applications, where you want run your computation on scale in parallel, and when you don't want to have duplication of your data sets. So let's say if you have, I don't know, a few terabytes of data of your images stored somewhere, and you need to do some operations with the data. So you definitely don't want to like have a couple more terabytes of like just because you just run, I don't know, some script, okay? And this is a huge problem for large companies. And this is why like they came to us and we try to solve their problems. There are like just few tools on the market about unstructured data management, and DVCX is one of them. It's not released. We plan the release later this next month in June, and like it works on top of metadata layer. So let's say your data saved in S3 bucket on Amazon or other cloud, and DVCX creates some tabular representation of your data sets with different annotations, different kind of metadata. And you can do sorting, filtering, you can slice your data sets, select some specific subset of the data, and save it as a separate data set. And when you will run your machine learning experiment, like DVCX will bring, like, download the required data files to your pipeline, and you'll run the experiments. So this is the idea, and this is what we are working on. And three main cases: it's LLMs, of course, where like we use huge amounts of data, multimodal applications, and computer vision. Okay, and like from the MLOps perspective, this is what is my core interest. So I'm lazy guy, and I want to automate everything. And when people run experiments and then try to deploy something, I don't like it. I just want to click a button or run a single command and see that everything works, and I don't need to do something else. So from MLOps perspective, LLM, generative AI, like actually have no much difference from classical ML. So it's the same workflows with some minor changes, but in general it's the same. That's why, like, when okay, so the same principles like can be applied to LLMs and generative AI. And what we see from the companies, from the industries when they came to us, is that many companies have like issues with versioning and reproducibility, especially in the biomed, financial industries, and some automotive computer vision, I would say, and also scalability and resilience. So this is like three core problems in machine learning applications. Today, like this combination of two tools, DVC and Ray, actually aims to solve these core problems. And today we'll talk about data pipelines and training pipelines, how to make them scalable, how to run them in parallel, and and still have some like benefits that DVC provides. Like it's actually GitOps, when I can commit changes into my code, into my Git repository, and it will triggers CI/CD pipeline that will run maybe new experiments, then check and validate model and data sets, and then deploy my model, something like that. So the DVC actually like brings this GitOps stuff. And Ray is an interesting tool. It's also open source that have its own libraries specifically for machine learning, but the core functionality actually is ability to run your pipelines and computational tasks in parallel in distributed manner. So today, previous speakers talk a lot about models, that LLM models, they are like huge, and they don't fit into the single GPU, right? And OpenAI uses thousands of GPUs to train those LLMs. And this is actually, if I remember correctly, actually OpenAI used Ray to scale and run in parallel the training process for GPT models. So this is what Ray brings on the table. And we try to integrate those two tools, and it works well. And like here, some examples and approach how we can do this. So what is DVC like two tools like DVC and Ray? So what's the difference, and what kind of core features. For DVC, it's data versioning and pipelines automation. So you can write some, can be, no, okay, it's fine. You can have a simple .YAML configuration of your pipeline, and DVC will understand what computational stages you have inside and which order it should run your pipeline. And also, it can track the metrics of your experiments. When your experiment completes, you just commit everything to the Git repository. I mean, the changes in your code and hyperparameters, some metadata about your experiment, right? And DVC saves artifacts of your experiment data sets or machine learning models, for example, into some remote storage like AWS S3. Yeah, and for the array, so array can scale, array can give you some deploy and debug information when it runs like in parallel. And to adapt your code to the array, actually, it's not so like big deal. So here's example from the arrays get started, right? So for PyTorch script, the training function, you just need to change 3 lines of code here to make it able to run in distributed manner. And array can distribute like there are different strategies how it can run. For example, it can distribute data, allow different workers, and it can also train your model in parallel. So like not download the whole model in one server, in one worker, but just a part of your weights of the model. And so it's pretty interesting. But the idea here is to start with array. Well, from this perspective of the changes of your code, adapting code to the array, it's not a big deal. So you'll spend much more time to configure permissions for your cloud provider and how you'll deal with how to bring the code. Okay, so it's not in the part of data science and machine learning. It's mostly about like infrastructure management for the cloud. And array also provides some configuration file, but it takes time to make it work, actually. Okay, so idea use those tools together. And there are like few challenges if you want to use. Have anyone used any of these tools? Alex, great. Okay, have you used DVC or array? Great. Anybody tried Ray? Okay, you're DVC guys. Okay, so if you want to try this with Ray, you'll understand that DVC doesn't work well on different workers, right? So when you work with DVC, you need to have, like after you complete experiment, you need to have Git credentials, for example, to commit changes, right, in your results. What Array is doing, it takes your code, just put it into remote worker and runs there. And usually don't bring some results. So there are some complication. So, and in this example, we try to solve this. So how to run DVC on multi-node cluster, how to provide accesses to Git and access to the data on different workers, how to collect metrics when you have like your experiment is running on parallel workers, right? So this kind of stuff. And this complex diagram actually describes this. So I will guide, don't worry. So let's say the local is your laptop, your machine, right, without GPU, and you want to run it in cluster. For the array cluster here, it's like automatically Array automatically can spin on the new cluster on AWS EC2, right? And it just run it, create new cluster, and run DVC XP run command. The idea here that like DVC will actually, DVC exp run command is a command to run experiments with DVC. And what it does is just run some some custom code that you prepared, your machine learning scripts with a PyTorch or whatever. And we just put those scripts, adapt those PyTorch scripts to the array that I showed you previously. And actually DVC runs, so array runs DVC on the cluster, and DVC runs array script with the array API. Sounds a bit complicated, but when you did it like once, like you run this in a single command, right? So we just run this stuff somewhere in cluster, and when it completes, Ray brings all results to the single node, to the head node, all artifacts like all our models and some other artifacts, and from the head node, we can actually connect to the Git repository and commit all our results. So this is how it works. So it committed to the Git and DVC pushes the artifacts to remote storage. Any questions so far from the guys who used DVC already? Okay, more or less clear. Okay, Daniel.
I've used DVC with Torch Lightning a lot, and Torch Lightning also supports this multi-node training, and there was kind of no problems. The only note is I've used a single machine with a lot of GPUs, a lot of processes running there, and the metrics were committed only from the main or the head process, as you are saying. So I'm wondering, what is the problem specifically with Ray? Because with Torch Lightning, there was no problems. It worked out of the box.
It's not problem. It's just some specific features of how Ray works. It actually can run different part of your experiments in like the same experiment in the same stage, just different jobs on different machines. So it provides more flexibility in terms of distributing your computational jobs. And this like just brings some complications, but it's fine.
Okay.
Okay.
I'm not sure I understood, but okay, we can.
Okay, I'll show you later the example. Okay, and in our example, we had, sorry, how much time do you have? Great. We had two stages, train model and tune model. Yes, this is how it looks, the configuration looks on DVC side, like inside like dvc.yaml configuration. For the tune side, we have the command that we want to run in the Ray cluster. So we just script with some PyTorch and Ray API inside, right? And our hyperparameters, something like that. And here we just specify what outputs we have. For outputs for the tuning, it's just some best params.yaml file, single YAML file with the best hyperparameters we want to apply to during the training stage. That's it. So this is our artifact for this stage. Okay, so DVC can track all these metrics, of course, and this is how we propagate some specific some DVC environment variables to the array. So from the runtime class, so array automatically can take the name of experiments, some credentials, something like that that you need to, for example, to access your S3 buckets, and like propagate all these variables to workers. So workers could be different machines, actually, different servers. So Ray can do this for us. And if you use DVC Live to track metrics, you need to adapt this DVC Live logger to be able to upload some artifacts automatically to S3. So the point here, when you use DVC in a single machine, it saves all metadata and metrics into local files. But when you run it in a distributed in parallel manner, so you have two files on different servers, on different workers. And this is a problem. So here we used a simple adjustment to use S3 as a synchronization point. So we just upload that artifacts to S3, and after experiment completes, DVC like bring it back and commit. Okay, it can be difficult, yes, if you didn't use DVC, but okay, this is my time. I have 5 minutes more, sorry. Okay, and yeah, so after experiment completes, we pull the experiment artifacts back to the head node in our cluster and be able to commit results to the Git repository. So, in short, what we can, what this configuration brings to us, we can use DVC to run experiments with a single command to run it, and then commit results to our Git repository. So this brings us reproducibility. We can control versions of code and data we used during the experiments. And Array help us to distribute jobs on the cluster. And also it has a lot of stuff for debugging our pipelines, a lot of pretty good logging system. Yeah, and that's it. That's it. So the point is, if you have to train the large models that needs cluster and parallel computation, run in some distributed cluster. So take a look on Ray. It's quite interesting, and okay, after a couple of weeks, you'll get to use it, and it will help a lot of to save a lot of time and yeah, and resources to manage those clusters. And that's it from me today. Thank you very much. If you are interested into DVC or something like that, please come to the poster about touchless library, and this is our pet project where we use DVC, of course. And yeah, I can tell more and show maybe some examples. Thank you very much.
Thank you, Michael. Now it's time for the QA. Does anyone have any questions? Okay, there's a gentleman over there.
Thank you very much for the talk. I am curious about one thing. If we eliminate Ray functionality, which allows us to perform distributed experiments, and focus on data versioning, model versioning, hyperparameter versioning, and all that stuff, how is it different from using data lakes, like Data Lake or Apache Iceberg for versioning your data, and that gives you a lot of features like schema evolution, time traveling, and so on, and more classical things like MLflow to version actually your experiments, metrics, hyperparameters, and so on.
Mm-hmm. Yeah, good question. Thank you. I'm not acquainted with the two first tools like Iceberg and something from Apache, right? But I guess those two are for tabular data. We need data schema, right?
Basically, it's a metadata layer on top of files that are stored on S3, and they can support ACID compliant transactions or something like that. And it's more publishable when you work with some tabular-like data, for example, relational, but I guess it's not limited to that.
Okay, great. I think it's more like a competitor tools to DVCX. It also works on the metadata later and does something like that. So DVC, I think it's much easier, like the tool itself. So how it works is just take your data, calculate some hashes for each file or each directory, and yeah, and save those information with hashes to Git. And when you, for example, update data, DVC can detect that something changed there and understand which files, for example, changed. And the difference is just to keep those information, the metadata, it just uses Git. You don't need a separate system, everything inside the Git. It brings some limitations, like it becomes slowly on the when you have more than I don't know 100K files. And again, the DVCX, like the new tool we are working on, will help with that up to the billions of files. This is the difference in terms of MLflow. As I know, the MLflow doesn't MLflow create duplicates, copies of your files. If you want to save something into MLflow, it just creates copies. Is it correct? And this is not what actually DVC tries to avoid. Right? Remove this duplication, and this is not feasible for generative AI for computer vision. Again, because it takes time, it generates huge amount of unnecessary resources, and AWS will happily to charge you a lot for those to keep those data. Yeah. So this is different. So to keep metadata, DVC uses Git, and this is some pros and cons for this tool.
Got it. Thank you so much.
Thank you for the question.
Okay, any more questions? Gentlemen?
So I'm curious about, I've worked a little bit with MLflow, but honestly, in most of my jobs, we've always ended up kind of rolling our own. And honestly, I'm a little bit jealous because that always becomes a massive, massive project and takes a few people to manage the chaos of it. But as you were walking through, one of the things in my work we've regularly needed to do is, having automation of multiple models training at the same time and sort of split testing between them. So having a live champion challenger model and dynamically allocating as one consistently performs better, more allocation of the traffic towards that. These tools and frameworks, do you think they would be a good fit for automating something like that? Or do you think that would be something that gets built on top of this existing MLOps infrastructure?
Yeah, good question. So actually DVC is in terms of management of your experiments with ML models. So DVC is a competitor to MLflow. It has completely different approach, right? It saves all do the same stuff based on Git. But for example, to collaborate with your teammates, you can use you run experiment, commit it to the Git, and your colleagues can just pull all results to their machine and see and compare the experiments, see all experiments and compare them. And you don't need to have a separate instance for MLflow and manage permissions and manage security and this kind of stuff. From this perspective, it's much easier. If you want to run experiments in parallel, right? And I don't know, maybe track. So for parallel experiments, so Ray is probably more the better choice. So, and if you are talking about inferences, when you want to run few models in parallel and track which model performs better and maybe switch between them or manage traffic between them, I think that Ray is the tool that can help here because it has some specific library for inferencing. So yeah, take a look on Ray.
Perfect. Yeah, definitely will do. Thank you for that. And the other thing around the data versioning you were talking about for the models, so you can back up and see if you have two different models trained that they're on the same exact version of the data. Have you run into cases where you're working with incremental retraining and incremental weight updates or things like that, where you throughout time have different versions of the data contributing to the same model?
So DVC allows you to track all these changes. You'll see that something you have updates in your data sets. So this updated data generates new models, something like that. So yeah, you can control it.
Thank you.
Thank you very much. Thank you.
Okay, we have another question over there.
Hey, thank you. That was a great talk. One question I have. So for this project, DVC plus Ray, do you have open sourced? I mean, do you have a repo on GitHub, maybe some article to check out?
Yes, we have a blog post on dvc.ai, AI, dvc.ai, actually on this website. You'll find in our blog, you'll find a post about this and links to the repository there.
Awesome, thank you.
You're welcome.
So we won't have any more time for questions, but
yeah,
Mikhail will be available afterwards. So thank you very much. Okay, our next following talk will be via a live online link with Angelia Masnikosa from Meta, connecting to us from the United States. Angelia Masnikosa is a business leader with over 25 years in the semiconductor industry, managing and designing microchips for graphics, CPUs, and AI accelerators. She is currently a technical program manager at Meta, where she leads the development of Meta's next generation of training and inference custom ASICs. Angelia started her career at AMD, where she held engineering and management roles with Fusion SoCs, integrated and discrete GPUs. She was a senior ASIC design manager of the team who delivered display controllers to Xbox One and Sony PlayStation game consoles. You may also find it interesting that Angelia was born and raised in our hometown of Subotica. Her talk, Hardware for AI Workloads, Evolution and Trends, examines the evolution of hardware for AI, why are custom ASICs emerging as a preferred platform for AI workloads within hyperscalers, and how will hardware systems and data centers scale up in the next 4 to 5 years. Okay, Celia.
Hi, everyone. First, I would like to thank for this really nice introduction, and I would like to thank the organizers for inviting me to this event, and a warm welcome to all the guests in Subotica. I hope you like my hometown. You like this event where you can share your best ideas. What's unique about Subotica, let me mention that, is that we have decorated roofs. So some of the roofs in Subotica are really, really beautiful, and I always share that. And all my friends call it the city with decorated roofs. So please share that and pass that word about Subotica. It's a really great European city. So my name is Angelia Masnikosa, and as introduction said, my whole career has been dedicated to designing microchips, or what we call it in industry ASICs, application-specific integrated circuits. So I'm gonna use that term interchangeably, microchips or ASICs. It's the same thing. And today I'm going to be talking about evolution, right? What was the hardware, initial hardware which we used for the AI workloads? What is the lay of the land today, and where are we going into the future? So with that, let's start. So timeline of machine learning accelerators. Initially, researchers used x86 CPUs, so Intel or AMD, to train their models. And that worked well, and machine accelerators workloads evolved, and Intel and AMD started optimizing for this particular use cases. They offered fixed point arithmetics instead of floating point arithmetics, which has a little bit more overhead to it, right? And they offered SIMD vector operations. So what is SIMD? It's a single instruction, multiple data, or vector operations, right? Where one instruction can run on one ALU, but there are parallel data paths. So essentially, that's how we process vectors on x86. But then at the same time, NVIDIA and their genius CEO and founder, Jensen, realized that these workloads really need a lot of parallelization in terms of processing power. So they offered their shaders, which were used to process pixels. They came up with this unified architecture where shaders can process pixels and vertices. And that really was the key for for fitting some of the machine learning workloads that have a lot of parallelization, and execute in this parallel shaders really, really well. And from that parallelization, we get a lot of acceleration of operations. So NVIDIA offered SIMT, single instruction, multiple threads. So it's a multi-threaded execution environment. Where one instruction can span many, many threads. So we're talking about 10, 50, hundreds, or even thousands of threads that are executed in parallel simultaneously. They're executed in lockstep, right? Processing the same instructions on a different set of data. Basically, that fits really well with the GEMS, with general matrix multiplication type of operations. So the key differentiator between NVIDIA and x86 on one side is SIMT versus SIMD. And because of its really best fit with the machine learning operations, SIMT took off, right? And then all machine workloads started running on SIMT. On top of that, like cherry on top was that CUDA software framework, which all of you are familiar, and which really simplified the use of GPU hardware for machine learning and deep learning. So that's how they took off. But I should say that there's always a percentage of ML workloads that will run on x86 architecture to this very day, right? What percentage is that? Initially, it was 80% was still running on CPUs. Now it's these days probably much less. And then post 2010, NVIDIA, continued with optimization of their architecture for deep learning. They offered concurrent kernels. They offered some, power efficiency optimizations, more CPU offloads, and especially, important for this kind of architecture is memory, so memory bandwidth. But they offered memory error correction as well. And around 2012, when AlexNet won that ImageNet challenge, right? I would say that's and that was that was with NVIDIA GPUs. Then it really took off, and then it's the deep learning boom on GPUs has started. With the Tesla architecture in 2016, NVIDIA offered NVLink, and that's a really super optimized interconnect between NVIDIA GPUs, and that offered DL training on multiple GPUs, right? So training can span on a number of GPUs. They offered half precision with FP16, which is the most optimal, numeric for DL workloads. And with Tesla GPUs, they just added a ton of compute with 125 teraflops. So we're in petaflops today. But interesting thing happened around that time, and Google came up with their TPUs. And TPUs were microchips really optimized for matrix multiplications, right? That's the only type of operations they're doing, and they do it the best, right? And then offer that in the Google Cloud. And that again changed the landscape. So let's look at the lay of the land today. So today, you know that NVIDIA is just continuing with their roadmap, H100s and then B200s. AMD has offered something competitive recently with their MI300s and MI400, MI450s, right? So they're competitive now. These are, primary hardware that's used for machine learning acceleration today. But if you look at the, there are many other custom chips that are developed by big names in cloud services. So these hyperscalers, what we call them, right? Google, Amazon, Microsoft, Meta, they all started developing their own custom chips for processing the workloads. So Google has a roadmap of TPUs. Amazon has targeted chips for training and inference, Trainium and Inferencium. Athena is Microsoft's chip in 5 nanometers for training, and then they have a collaboration with a startup for their next generation of the chip called Praga. Meta has Meta training and inference accelerators, and then Tesla has Dojo. So it's very interesting, right, what's happening. And then recently, even IBM came up with their own custom chips for training Watson models. So why is this happening? Why do these hyperscalers need their own custom chips where there is really strong roadmap from NVIDIA, from AMD, and then CPUs from Intel? So one of the reasons is the cost of GPU today. So one such a GPU costs like a really nice car. So it's 30 to 40, $50,000. But that's not the primary reason. However, it is a big reason, like given the scale of this hyperscalers need, given the number of GPUs they need, it is a pretty big number. And NVIDIA's revenue keep growing up $3 billion quarter over quarter, right? They're adding $3 billion every quarter. So while it is the price is huge, but the real problem is you cannot get them. Right, so there are just supply constraints. They cannot make enough GPUs to meet the demand today. And then also coming out of the pandemic, right, there were supply chain issues, right? So in order to smooth that supply, right, hyperscalers are turning into their own chips and their own supply chains. And then one big truth is that GPUs just are not designed for inference. They are very powerful in compute power and memory bandwidth and memory capacity, but they're just too expensive for inference, right? So there could be further optimizations there. And in terms of power and then feature and instruction set, GPUs are very general purpose. While knowing your workload, you can optimize chips around power and features. You don't need all the features that NVIDIA offers. And then further, you can optimize the instruction sets. So narrow it down to really operations or numerics that you need for your particular use case in training or inference. Another interesting area where there are many optimizations, and the hyperscalers are especially good in that, in optimizing the time to production, right? So owning the whole development process from end to end, so from chip design to chip deployment in the data center, hyperscalers can optimize that time to deployment. And another thing that they're monitoring really, really closely is the total cost of ownership. So it's the price of these chips and then hardware that goes with them, right? Servers. They can optimize the integration time, the maintenance once the hardware is installed in the data center. They can optimize repairs and then training of the staff who work in the data center, and then also decommissioning process, right? So all of that adds up at that hyperscale, right? They may end up saving billions and billions of dollars with their own chips. Another very particular, area where people are paying a lot of attention is developer efficiency. So we talked about CUDA, how that enables that developer efficiency in acquiring the knowledge about that hardware. And then there are further optimizations that can lower effort to deploy hardware into the data centers. Basically, like you can add a further layer of software like PyTorch, right, on top of that to provide the ease of use for chips. And as you know, the model growth in size, we went from, we're now in gigabytes, terabytes, and complexity that of compute that's required, right? It just keeps growing. And right now, we cannot fit any model in a single chip, right? We need a network of chips, and we need to build large platform solutions, large clusters to be able to train the demanding models that we have today. And then also, hyperscalers are customizing the whole stack to the workload. So it's a chip, it's the boards, it's how the servers are designed, racks, and then how the data centers are designed, and logistics, or where are the data centers located. So all of this is the reason why hyperscalers today want the total vertical integration, and basically they want to control their own destiny. So what do these chips or ASICs for machine learning look like? Well, they consist of a mesh of a processing cores, and these processing cores could be, Atom-based x86, or they could be ARM-based or RISC-based cores, or they could be totally custom cores. And that's where we perform matrix multiplications and nonlinear functions. And there's a ton of data movement between the cores and between the cores and memories. And there are on-chip memories, caches, and then off-chip memories as well, low power DDR memories, or high bandwidth memories, or a mix. And then they have highly customized instruction sets, right? When we talk about custom chips, then instruction sets and numerics are very specific, optimized for the workloads. And there is always a host CPU somewhere and on the board that coordinates execution between chips, multiple chips on the board, or between these cores. So there's always a CPU that is a host CPU, and that boots the platform and controls the power management and controls the spanning of these jobs into accelerators. And there's a PCIe or CXL cache coherent interface to that host from accelerators, and then there are extensive debug system to debug the operation of these chips in the fleet. And then key for deployment of any hardware in the data center is the security and reliability, right? And especially reliability, like if there is any error, how do we restart the hardware as soon as possible? There are network interfaces and a NICs network controller, right? So this chip, when one chip talks to another chip somewhere on the same rack, or in somewhere in other location in the data center, or between two data centers, there's Ethernet connection, right? High-speed Ethernet connection between them. And in terms of architecture, there is a scaling up. So these chips talk to each other on the same rack level, or scaling out between data centers. The key and then the art to designing custom chips for machine learning is really finding that fine balance between computation capacity, between network bandwidth and memory bandwidth, right? So that's where we optimize the most to find the right balance and to find the right power performance ratio. And then with the latest trend in advanced packaging, it's possible to package multiple of these chips into a single package, and it's even possible to stack one on top of the others. So we have 2.5D or 3D packages with all the advancement on the chip packaging side. And of course, cooling of such chips is the key. So there's air cooling, but there's more and more we are seeing of liquid cooling of such hardware. So is there a difference between inference versus training? So I mentioned earlier that those workloads have a kind of different kind of demands. So training requires everything, requires compute and memory and networking, it requires reliability, and training jobs run on the really large cluster build-outs, right, on many chips. Training lasts a long time and therefore requires resiliency and short recovery time should an error occur, right? Recovery has to be short, or otherwise at that scale, it would be a problem. Right? It would stall the whole training. Error attribution and then the fault indication is key, right? Finding out where the errors are in the data center, right, and fixing them or restarting hardware in the minimum amount of time. It really adds up when you have a training job that lasts, days or weeks at a time. And then inference, on the other hand, is computer memory intensive at different times, right? So if you look in maybe in language models, that time to first token, right? The time when you ask something to get that first response is very compute intensive. But then time between two interactive tokens, right? As the model is reading from the memory, right, and reading those responses, that's really memory bandwidth intensive, right? So time to first token requires compute, and then time between two iterative tokens is really memory bandwidth intensive. And there are some custom accelerators that offer fungibility between training and inference, and large clusters that are built for training may end up being used for inference as a secondary use case. And so let's talk about what's coming, what's the future 4 to 5 years from now. The size of this clusters of chips and the size of the data centers will scale to zettabytes, and we're going to enter zettabyte era. So not that long ago, this was the size of the whole internet. And you can think in a few years that whole internet from just 10 years ago will fit into one data center, right? So zetta scale, zetta is 2 to the power of 70, right? So it's just mind-blowing how much data is that for a single data center. And then you can just think about, all the problems that arise there, like cooling, but also the power consumption of such data center. It's going to be in gigawatts. And it's going to need a nuclear generator, to power such a data center. Which is why it's projected that the power demand, which is growing with 15% CAGR, is going to reach 50 gigawatts by 2030 in the US. Right? So to power all these data centers in the country, we'll need 50 gigawatts, right? And most of it is going to be nuclear power, right? You just don't get that much power from some other more sustainable power plants. So if you want to invest anywhere, invest in uranium or invest in copper, and then you can just imagine how much copper will be needed, right, to wire all those data centers, which is why the price of copper is just going up these days. Same for uranium. And what kind of advancement, right? So all of that will be possible by advancement that we have in microchip industry, right? In semiconductors, right? So it's all driven by these small chips. So to really reach the scale of compute that we need, we're going to be using the entire silicon wafer to create one super chip. So you can see a silicon wafer here on this picture, and then today it's cut into small chips, and then that are packaged into packaging, chip packaging. But in the future, we're trying to use the whole entire silicon wafer to create one super chip. And of course, there are many problems with that. Power dissipation is one problem, but also defects, right? So this wafer is really big. It's 45 centimeters in diameter, right? And then naturally, there are some defects occurring. So we have to have like a really low defect process and really high yield for those wafers to be able to use a whole thing for one super chip. So there are some startups doing that already today, and you can see a picture of such a chip. And another enhancement that we need is really boosting that bandwidth between chips. So we will need optics for that. And into chips, right? So there will be lasers in this package to really power those optical networks between chips, right? So we have optics, between racks, definitely that use a lot of fiber optics, but I'm talking about smaller scale chip-to-chip communication, right? I mentioned NVLink that is optimized chip-to-chip communication based on PCI Express, but in the future that will be optical as well. And then finally, all these advancements will lead to an age of artificial general intelligence, AGI, and AGI will be capable of reasoning and then complex problem solving, unlike some of the models today, which when you interact with them, right, you have impression that they go into some lookup table or they search internet, right, to get their answers. But AGI will have reasoning, right? So interaction will be very different. And I hope all of you will get a chance to contribute to AGI one way or another. So that was my presentation. Thank you very much. And I think we're going to turn to questions now.
Thank you.
Hi, thank you very much for the presentation. I have a question regarding like the RAM, which is with the GPU. What limits the scaling? What limits the vendors of the GPU on just adding more chips? Like it seems it is not problem with with CPU because you can add more and more RAM. Yeah, why can't we do this with GPU?
Why we cannot add more RAM to the GPU? Sorry, I didn't really. So your question is about CPU and GPU difference, right? Correct?
Yeah. Like what limits on scaling RAM on GPU compared to because it seems to be working on CPU.
In terms of memory bandwidth, CPU versus so GPU uses HBM recently, right? Especially for I'm talking about the GPUs for machine accelerators. So they use HBM, right? And in terms of scaling the memory, I don't see the difference, right? In terms of capacity, CPUs, GPUs have the same capacity available. But what's the difference is that multi-threading, as I talked, right? So that's the key, right? That CPUs don't have that much parallelism, right? But Xeon CPUs today, they all have HBM, and they all have the same technology available, HBM3, HBM4, right? And maybe GPUs. You think about GPU as they use GDDR memories, right? They're a little bit much faster, right? But then they use more power as well.
And okay, and why don't we have like, I mean, the industrial level GPUs, they have at maximum 80 gigabytes, which again, like, it doesn't seem to be a problem with the, on regular RAM compared to regular RAM. I mean, I have a computer which has like more RAM than most of the industrial level GPUs.
Oh, they have industrial level has much more than that, right? The key to the key problem, right, with the memory is von Neumann's bottleneck, right? Is that the bandwidth, right? So I can tell you that there is a lot of research, right, around von Neumann's bottleneck, right? Because we have to load store operation, right? So that's why one approach is to add more memory and then to add faster memories, right? But there are another approaches, especially on the custom accelerators, where we can add a lot of compute in memory as well, right? So maybe you heard about that, right? But capacity itself, CPU, GPU, I would say we are there. So, but I'm talking about a big scale hardware deployed in the data center. So I think your question may be more about maybe PCs or stuff that home computers, right? We are not as limited in the data center on memory bandwidth and memory capacity.
Thank you very much for answering.
Oh yeah, sure. Hope I answered your question.
Hello, thank you for the presentation. Not long ago, AI scientists were ridiculed when they tried to predict when AGI would arrive. But today we hear from many leading AI people assumptions that it will be from 1 year to 10 years. What is your opinion?
2030. Right. So but I'm talking purely from the hardware roadmap, right? I'm seeing that happening, at Google. I'm seeing it happening at Microsoft as well, right? Possibly. And we need some advancement, right? As I talked about on packaging, we need some advancement on liquid cooling, and we need to build those data centers. ASIC design process takes years, right? So we are designing today for those workloads in mind, right? So from hardware perspective, we'll be ready in 4 or 5 years from now. So we will be ready, and I think some of the build outs are being planned already.
Thank you.
Question over there.
All right. Hello, Angelia. It's nice to be in your hometown.
Glad to hear that.
What happened with AMD graphic cards in recent years? Why they are like inferior to NVIDIA ones? and what will happen in the future with AMD. So will they rise back to the hardware race? How do you see from your perspective?
I think they came up with a competitive offering recently. So I'm not too worried about AMD at this point, right? I'd be a little bit worried about x86 architecture versus ARM, because now you're seeing PCs with ARM, so I'm seeing a little bit more competition, but I think AMD is positioned well, and they're competitive even on the high end. They're competitive in NVIDIA, and really the market needs a second source for GPUs, right? So talking about supply chain issues and talking about hyperscalers. They are making sure they have a second source, so they will always give some portion of their business to AMD in terms of their GPUs.
All right, thank you.
We have time for one more question. I think that's it. Thank you, Angelia.
Thank you, and enjoy, guys. Thank you. Bye.
Okay, so our final session for today is the panel discussion, leveraging generative AI, emerging trends, and real-world market applications. The panel will be moderated by Goran Milovanovic from Smart Octo, and his panelists will be Branko Kovac from Logica, Tadej Kurepa, Program Manager from Venture an Idea Project, and Mikhail Roskov from Iterative AI. This panel explores the dynamic intersection of generative AI technologies and market applications, highlighting emerging trends that are reshaping industries. Stage is yours, guys.
Hello, everyone. So, as in every machine learning conference, the funniest part, the panel. So, first of all, thank you, dear guests, for joining us. Mikhail, Tadej, Branko. Branko, did you miss a single panel on the machine learning conference since its onset? One,
yeah,
probably?
one.
Okay.
But last year we had a meetup, and then the
That's
first
true.
day there was a panel, so I did it twice.
That's true. That's true. Okay. So, anyways, this is how we have conceptualized this panel. So, I will be moderating the panel. An important thing is that in all previous editions of the machine learning conference, during the panel, it proved that actually the audience really took part in the discussions, and we like that very much. Okay. So, hopefully the questions that we will discuss are going to be enough thought-provoking for you to engage, but do not wait for the panelists or myself or our secret competitor, which will soon join the quiz, to answer to everything. So simply jump in, ask for the microphone whenever you like, get engaged. We really enjoyed this game in the past in the machine learning conference, and we also are looking forward to enjoy that question today. So the secret competitor in this quiz is, believe it or not, large applause, please. So this is how we are going to do it on this occasion. Look, so we have some pre-formulated questions during our preparation. So I've talked to our speakers, we discussed, and asked them to simply suggest 2 to 3 questions that they would find, interesting to discuss in the line of this discussion. Okay. So we will begin by selecting a question by question, and then every participant in a discussion, they can motivate the question or explain why the question is important. Then we will simply ask our artificial intelligent friend to propose, to suggest a response, and then we will comment on the output and see whether that actually worked, or if the human expert would do better, So look, I mean, all these people are really my friends. I do not mean to, simply compete you against the... They are really experts. They are my friends. So, guys, don't get this wrong, okay? So it's like I would like to keep your jobs and whatever you do, okay? Good. So let me see. So where is the setup? Is here? No, the setup is not here. It is here. So the first question that we will consider is from Tadej Kurepa, our friend from the Digital Serbia Initiative, and also the program director of the Preduz Mi Ideju, which translates to English how? Venture and Idea Project?
Venture and Idea,
Venture and Idea,
yes.
that's better. Okay. So Tadej's first question was, his suggestion, what should we discuss is generative AI bridging or creating the skills gap in the workforce? Tadej, perhaps you would like to motivate it a bit or provide some additional context, how you're thinking about it, and then we will go for ChatGPT, and then we will see how do you cope with AI.
Well, I suppose that ChatGPT will have some kind of, optimistic viewpoint on this, but this is actually a trick question. So what I wanted to answer, if you ask me that, it would be that there is a global gap emerging, that it's not only a skill gap in the workforce in one country, but it's complex global gap. And last year I was at Stockholm Internet Forum. It's a conference on democracy and human rights in the context of new technologies. And it's global conference. There were people from all over the world. And one of the main concerns by people from, let's say, a global south, especially, I don't know, India, Indonesia, and so on, and Africa too, was that the companies from center of the world system, from the US and European Union, will use their data to train models and then sell these models as services to these countries, and that people from these countries will basically be that this will continue to increase the existing gap that we have already in the world.
Okay, so you can see a typical human here with empathy, worried about the consequences for the humanity. So let's simply shoot it out to our friend. Okay, generative AI has a dual impact on the skills gap in the workforce. It can both bridge and create skill gaps depending on how it is implemented in the context in which it is used. Let's explore both sides. Automation of routine tasks, enhancement of creativity and productivity, training and upskilling, augmented decision making. Okay. Should perhaps I instruct it to be concise and answer in the 2 or 3 paragraphs, huh? Add some prompt engineering to it, okay. So look. Okay, dear ChatGPT, so be concise in your answer. So be very concise in your answer. Concise in your, sorry, in your, I have only one hand to type. In your answer, okay, so this LLM things, as you know, they cannot count, right? So they don't know arithmetics, but I will try. So use a paragraph or 2 at most. So I have a typo here, a paragraph or 2 at most. Ha, that's one paragraph. So generative AI both bridges and creates skills gaps in the workforce. It bridges gaps by automating routine tasks, enhancing creativity and productivity, and offering personalized training and upskilling opportunities. This allows a broader range of employees to contribute effectively and adapt to changing job requirements. However, it also creates gaps by increasing demand for specialized AI skills, adding complexity to AI tools, potentially displacing jobs reliant on routine tasks, That's true. And necessitating new ethical and interpretative skills. Balancing these impacts require investing in education, promoting inclusive AI development, and supporting workforce transitions. But look, I mean, it included promoting inclusive AI development, right? Didn't it? In this one single paragraph. So what's the difference? How would you compare your response and your elaboration of the question to this thing?
Well, first of all, I intended to use the question as a trick question. So in a way, but thinking about the question, if we ask, is it you know what is the bridging of the gap and what is the creating of another type of gap? I feel that for those of us who use it regularly and intensively, it can reduce the need to consult experts because at some point, you know, because we can navigate and reason, let's say, a domain that is not our own, and you know, to dive in something and get structured information that we can understand, and in this way, I feel it's bridging the gap. And at the same time, we have. I can go back to what I previously said from a different perspective. And you have a measure of the penetration of ChatGPT in the workforce, and it's basically connected with the economic power of a country, and that in poorer countries, people use less ChatGPT. It's less percentage of workforce that is exploring and using Gen AI in any way, and AI tools. So it's again increasing productivity of those who are already on top, and it is creating this
It's widening the gap.
It's widening the productivity gap.
But isn't that the same as what happened in the introduction, the penetration of the internet such? So we learned about the phenomenon called digital divide, which is still with us, right? So it seems that every technology does.
Every technology, not only digital,
does the same thing, right? There is something that I find deeply paradoxical about one part of the response from ChatGPT. I mean, this first elaborated response that I didn't want to read through, but so in his section, so the response was organized in sections, you know. So you have already noticed that ChatGPT 4 especially is crazy about bullet points and sections. So anyway, so bridging the skills gap was one part, and then comes the section called creating the skills gap. And there is a subsection called complexity of AI tools, and I didn't really like this because I find it deeply paradoxical. It says, while AI tools can be powerful, they can also be complex to use and understand. This can create a gap between those who can effectively leverage these tools and those who cannot, potentially widening the skills gap. And now look, so for the first time in history, we are looking at a computer technology that is arguably solving the very holy grail problem of computer sciences since the inception of computer sciences, and that is the problem of human-computer interaction in natural language, right? So putting aside philosophical questions, whether this thing passes Turing's test or not, I think it does, by the way. But I also agree that it's disputable. It's a matter of a discussion. So, for the first time, now we have a technology which allows for a human-computer interaction in natural language, right? So people in computer sciences were looking for that for decades since Turing's works in the 30s and the 50s, right? Now we have that, and still, and somehow it seems that the problem of the complexity of technology is still recognized. Isn't that a paradox? I mean, This thing should make technology more available to people, right? And that's, I mean, way more available to people than before. Okay, so we all probably saw the latest OpenAI demo with this version of ChatGPT 4.0, except for those interactive features are still not rolled out. I cannot demonstrate them here. You can interrupt the assistant and you can really engage in a real discourse with them, with real dialogue, which means that very soon, and I mean really very soon, you will get operative systems that you can talk to and they will listen to you, right? So how does that widen the gap and ask for more skills? In my perception, it looks like it's asking for less skills and not more skills. You don't even need to know to type anymore, right? Mikhail?
Here is an interesting point in our discussion. We assume that those points are true.
Oh yeah, absolutely.
Okay,
but it's ChatGPT.
But we discussing them, right? Like those are true, and they actually worth our time to discuss all these points from the true perspective, right? But this is interesting. Just wanted to point that this shouldn't be like this, right? Or we like if the models will be very sophisticated and we'll have that AGI and they will be like generate some true reasoning, then probably it will not be like the problem with the gap skills, right? Because like people will just ask and get the clear answers and they will be right. The problems with the gap skills like prompt engineering and we have at the current level of technology development. It's not that because it's just because the LLMs are not good enough and they don't understand that the context and how they generate responses. But
that is
just
true.
interesting point that
that's
we
a very
just
important
accept
point.
assume those are correct and we discuss.
That is true.
Interesting,
That's true.
right?
That's the part of the anthropocentric perspective. We're almost looking at this thing as if it were magic, right? So if ChatGPT produces it, it must be true, which is, far away from truth as it can be, right? Okay, so look, I would like to skip to the next question, and this is from Branko Kovac. What are the challenges? You remember when we started the data science community back in 2015, 16 or something like that in Belgrade?
Not anymore.
You don't remember it? So, and if someone would told you in those early discussions back 7 or 8 years ago that we will actually see a technology like this in our lifetimes, what would we say?
Yeah.
No way.
No
chances like this. Yeah, this caught everyone to a surprise. So Branko's question, what are the challenges businesses face in adopting generative AI? How can they overcome it? What are the challenges businesses face in adopting generative AI? How they can overcome it? And I will add, be very concise in your answer, use a paragraph or two at most. Let me see if you did learn to count since my last prompt. First paragraph, not second paragraph. Don't forget about it. So LLMs know no arithmetic, believe it or not. So it seems that the syntax of natural language is easy for them, but simple arithmetics, logical operations like that, they simply do not listen to it, have no idea what formal or symbolic systems are, and counting is, believe it or not, a symbolic system. So Branko, this is what ChatGPT says. Businesses face several challenges. Let me see if I can put this somehow. No, unfortunately, I cannot scroll that screen anymore. So businesses face. Say.
Can you ask to make it in key bullet points? So maybe it will be easier maybe to read them.
At your service.
You can just message like, give me bullet points.
Sorry?
Bullet points, please.
Challenges in adopting generative AI. High implementation costs, data privacy concerns, integration with existing systems, shortage of skilled personnel. So it's still pushing it into the direction it actually likes. Strategies to overcome these challenges. Invest in scalable AI solutions. This is for you, Michael. Implement robust data governance practices, prioritize seamless integration with current infrastructure, focus on upskilling and reskilling the workforce, partner with AI experts and leverage third-party AI providers.
Do you find this
What do you think?
too generic?
No, definitely, but that's because of the bullet points that Carl asked us. Well, you know, we can also grab and elaborate, while we discuss, we can simply grab an elaborated response, more elaborated response, and
I'm not sure
it,
that it's going to give us more than this. I don't know. I mean,
sorry.
I was hoping, or I'm still hoping for something different, but no.
Wow. Development and deployment of generative AI systems requires significant financial investment. That is, I think, good leading.
It's a good one. I'm glad that it's the first one, but I didn't want to mention it as the first one. Anyways, recently there was an article, I don't know, Verge or something, trying to quoting it was Zuckerberg, and he said it will take many years before we see any real revenue or profits coming from Gen AI.
Do you have the same feeling that I do? That I mean, of course, these are black boxes. Nobody, you know, players like Anthropic or Google or OpenAI, Microsoft will not reveal the cost structure of these things. That is, I mean, completely expected. But I really, you know, I suspect that the inference costs running this large machinery is, I'm not even sure if they still get any real revenue from it. Or is this still an investment game and then we'll see one day?
It seems to me that it's pretty much
if
like
there is, there is real revenue.
Yeah,
it must be
the
marginal.
last man standing, pretty much. Yeah, it's going to be like, I don't know, multiple year-long competition
until they really start making money.
Yeah.
And here we are talking about big tech, not to mention small and medium players who reuse, do retrieval augmented frameworks and similar things.
And when I was thinking about this question, what I had on my mind were not big tech companies, but actually rather small businesses, right? And yes, this definitely is a good thing to mention.
Yeah, that's a discussion that I hope to have, because I have the feeling that we are still, I mean, it will be 2 years in November, end of November 2024. It will
since
be since the onset of the free version of this 3.5 famous model, right? And I still feel that business-wise, we are still in the waters of a narrative and not really in the waters of real revenue.
We are still in waters of really not understanding what we can do with it and what we cannot. During the break, I had a call with a good friend of mine and a business partner, you know him, discussing potential interest from, let's say, regional marketplace player, blah, blah, blah. And I said, hey, you know, they would like to have some kind of assistant. And he said, oh, okay, another one, right? He said, like, what exactly do they want? I immediately responded with, I don't know, and they don't know
and
as
they
well.
don't know.
So I see that, because what was the question originally? Can you just...
the original question was, it was your question.
It was my question, but I just want you to quote me.
What are the challenges businesses face in
main,
adopting Gen AI technologies?
While costs are definitely a challenge, I still think that businesses have like real lack of understanding what systems like this really can do or should be doing, right? And then we are seeing a lot of shiny demos, right?
Absolutely.
Making huge promises. And on the other hand, nobody really talks about costs. Everybody wants it now, tomorrow, in a couple of months, which probably opens a couple of those, you know, bullet points there that are also mentioned.
Certainly does,
right?
cost-benefit
But
analysis,
at the very end, if we are going to rank these, right? Challenges, I would say, challenge number one is really lack of understanding what this AI
I would really
can
agree.
do.
That it's
You
not
know, it
not-
comes before all these.
Yeah. It's not really financial, it's not really ethical risks, it's not really all the things that are super popular in discussion, the narrative nowadays. The real thing is, do you get it? I mean, what these things can do and what these things cannot do.
I mean, the same thing existed with machine learning, right? Traditional machine learning.
I will
with this, it's just like, I don't know, multiple times amplified.
Just to illustrate, I will add a real-life anecdote from when did that happen? That must have been this 2024. Well, as early as autumn 2023, it might have been October or November, I had a conversation with, well, let's say a serious business in this country respective to the industry we are talking about. So it's not the most proficient of the industries, but they're, let's say, the other conversational party didn't really have a real business competition in what they were doing. They were excellent. Talking about the potential application of these things, and we were having coffee for a first, conversation breaker, just to get to know each other. They were asking things, etc. And they were very enthusiastic about training an in-house large language model in Serbian for their proposals. And I was like, you're a dreamer. I mean, you will see one day. I was like, okay, I will see. No problem.
Did you see?
Sorry. Well, not really, because nowadays we know from the research that actually Slobodan Markovic and all people involved in this, and also what Alexa Gordic does with YouGPT, we know one thing's for certain, and that is we simply do not have enough training data. Taking all the digital footprint in Serbian, Bosnian, Croatian, put them all together, and it's still not enough to train a large language model. And I was not really sure about the hardware that those people envisioned to train that thing.
That was the next thing, right? I mean, even if you have data, then
exactly. The next thing
question
is
of costs.
Absolutely.
Right?
The next
Not
thing
just,
is
in terms of training the models, but also later, right? Because it costs to run.
So I kind of agree with that. So here is, probably this is a by a book solution offered by
I would say
GPT-4.
it's a very good list, assuming that company or business actually does know what it wants.
Yeah. But I'm not sure that really people actually understand the question that you asked. So do you really get it? I mean, do you understand what you can do with these technologies and what you cannot do with them? I'm sorry, I had Tadej and no? Okay.
Yeah.
Please.
Yeah. So, but I think there is another gap we can talk about here, and that is gap between this fear of missing out that is forcing a lot of companies that can afford to go into Gen AI, and I'm getting daily updates from different softwares and apps that I'm using, that they are introducing AI in this or that way, and most of the time it's just unusable or irrelevant. But at some point, someone in some of the industries will realize what you are saying, that they don't know now what do they want. Some people, some companies will start knowing what they want, and they will start implementing it. And I think there is a concern from my side and risk that some of our companies, not IT companies, but traditional companies, will understand how Gen AI can be used in their domains when they see their international competition rolling them over using Gen AI.
Doing that.
And this is why I think we need, as a community, to interact with traditional companies and traditional industry in the country to help them get there at least at the same time as their international competitors.
Well, that would be beneficial, but I really have to be, let's say, conservative in my response to this discussion, because what experience taught me from previous discussions with companies in the Serbian market, Serbian companies in the Serbian market, is that they simply don't listen to you. And that is a problem. But that's more of a cultural, in a sense of the organizational cultural thing, and maybe more of a debate on management than these topics. But I agree with you that strategically it would be important to show them the way and say, look, this might happen, and then someone can simply buy you out from the whole story if you don't do it. Sorry, do I have a question from the audience? Please, Tihomir.
Hey, thanks. Well, I just wanted to kind of lay down my 5 cents because I had an opportunity to hold like 4 workshops for about 100 people from traditional industry kind of to discuss the usage of generative AI. And what I've learned is that there are no company policies on what should be used and how. There are no kind of widespread adoption of Gen AI tools inside of companies, let alone to kind of face their users and enhance their I don't know, products or services they offer. But what I've seen is that individuals are using Gen AI to enhance their work like on their own, but the companies just kind of don't care, or there's no initiative, or the leadership is not educated enough. So what I've concluded is that it's just kind of the early adopters are using Gen AI, at least here in Serbia and a bit wider in Balkans. And I haven't seen kind of, you know, strong kind of use case for AI that they could potentially copy from each other, kind of, oh, they are using it, I'm going to copy their model onto my company. So have you seen kind of any shining examples of Gen AI usage here in Serbia on a company level, not on the individual level?
No, I don't think so. I haven't. But this is very similar. Your claim is very similar with what Nebojša Bjelotomić actually said during his keynote, right? So the small and medium players are still afraid that's risky for them, okay, while the big systems are simply slow, right?
Yeah. Thanks.
Sorry, I'm not sure. Did we have another question from the audience?
I believe there was
like
another hand.
Missed some. Okay, so I don't know what mic is going to travel. Okay, a moment. You will be delivered the mic. Thank you.
Yeah, I was a few days ago at a similar panel, and I heard of implementation at a local large e-commerce company that probably everybody has heard of. They actually use 17 different AI services internally to generate content, to analyze data, and so on. So there are some implementations.
Internally they use it, right?
Mostly internally, yeah.
But is that, do they do it in an organized manner?
Yeah.
In a sense that was a managerial decision, it was implemented top-down or whatever way, or we are simply talking about a compilation of what their workers what the employees are simply doing with it?
It was from the CEO, and he said that they have 17 different AI modules implemented in their workflow.
What's the company?
Ananas.
Sorry, okay, that's a tech company, right? So yeah, I'm in Smart Doctor, we do everything with it. So I'm not sure that's comparable with the question. We are talking about somebody who's selling milk, right? I'm not that much worried about tech companies. Yeah, we do it, of course.
So 17.
Yeah.
Okay.
Not bad.
I will remember that.
That's good.
We probably should distinct using API, Gen AI, right, from developing some Gen AI models internally, like generate.
No, I mean, the Ananas is, I don't see an Ananas as a relevant example simply because Ananas is in itself a tech company.
Yes,
right?
I understand. I mean, what we're discussing, if we're discussing like talking about challenges and problems when company like apply, like use this as a commodity, those services,
exactly.
they will get a lot of benefits in text generation and image generations using the already services, right? But if the company wants to build their own models, This is where the problem starts.
That's different, yeah.
Yeah,
Absolutely.
and if I understood correctly, the Ananas uses that services ready, like ChatGPT. It will boost a lot of productivity of users, right? And this is how a company can get benefits right now.
Yeah. I think I will personally forget how to program in Python and R since I started using this thing. I was like, good, you can earn the salary. So it's look, sorry.
Can you do like 1.5 minutes break because they need to reset the camera and we are recording? Just 1.5 minutes.
Okay, so it's now 11 minutes past 6. Shall we say 5 minutes, 60 seconds?
ChatGPT joke?
Good. Produce. Sorry. Sorry. I've just leave this.
This is intelligent slavery. Yeah.
So produce a joke on two generative AI systems entering the bar. Two generative AI systems walk into a bar, of course. The famous beginning, the bartender looks at them and says, "We don't serve your kind here." One AI replies, "That's okay, we're just here to generate some buzz." Well, this makes sense, by the way. It's good. Thank you. Thank you. It was a famous joke during my PhD studies in cognitive science. It says, in decision theory, an expected utility maximizer enters a bar, walks into a bar, and then goes decision theory along the way. So this is not bad. So look, Mikhail, you had formulated the following question. So what are the main technical obstacles in developing and using Gen AI for real-world applications? So I'm not sure, knowing your background in MLOps, I interpreted the question in one way, but I'm not sure whether GPT did the same. So I will just go through the sections, the bullet points. So once again, the question was, what are the main technical obstacles in developing and using generative AI for real-world applications? Data quality and quantity, computational resources, specifically referring to high computational cost and scalability, model complexity and interpretability, generalization and robustness, generalization, we know what's that, robustness. Can be sensitive to small perturbations in the input data, of course. Ethical and social considerations, bias and fairness, misuse, integration and deployment, integration with existing systems, deployment, legal and regulatory compliance, who cares about this? Okay, so data privacy, intellectual property, maintenance and monitoring, model maintenance and monitoring. How does this sound? And maybe it would be good if you would provide the context, the background. How did you frame the question? What were you expecting? From real humans, not from ChatGPT.
Actually, I used ChatGPT to generate those questions, Why not? Okay, so what is the most interesting question about this stuff?
I use it to generate the abstract of these panels. So
yeah, of course. So
maybe we're not necessary.
This is how it works. Yeah, this is everybody is expert in generative AI with with ChatGPT. But the point is, like, I'm not a developer or researcher in generative AI, right? So deeply, right? So I'm mostly about the technical stuff. We work with companies who develop generative AI. And like those, that at least two first points with data quality, quantity, and computational resources. So those are like a true and valid points, right? And we already did discuss. So today we discuss about those 2 points. So it's true. So it costs a lot of money. It takes a lot of data. And also the last point about maintenance and monitoring. This is like just like this is like new how to say that, new area of in understanding how those models behaves and how we can monitor those. And only like a few new tools, I don't know. Just last week I saw that new tools came up to the market with a new functionality to how to monitor LLMs, because it's not clear, and now it's not robust because everything manually, and people don't version data and don't control data, what is goes input and what outputs, and so on and so on. So those are just the same technical problems that we have with classical ML.
Yeah, except for the classical ML, we knew about the training data, and now we don't even know what is being pushed through the LLMs in their trainings. I mean, not when we download an open source Llama 3 and want to fine tune it, then we know, right? But for these very large systems, and for those that actually want to self-compute, like Anthropic with Claude 3, like with OpenAI, Google Gemini, we absolutely have no idea about the structure of the training data anymore. That's
the problem is when you train some model, classical model for classification, right? You get out like a single number, like index for the class, for a label, right? And you can compute a single metrics that will tell you that the model good or bad, or like few of them, okay? With generative AI, so how you can
way more
estimate that one answer is much better than another one.
Way more complex.
Yeah, in technical
No, the
way.
problem is that, with evaluating responses of this sort, what LLMs give us, right? So typically, historically, that's the business of cognitive psychology, which is my basic academic field. And evaluating these responses from human beings is complicated, and we do not have an agreement on how would we methodologically evaluate the quality of those responses. There are different viewpoints, different approaches, too many of them, etc. And now we have to deal with these things. So I think we will be far away from standards in that respect, from reaching any standards in that respect.
This is an additional point to that maintenance monitoring and data quality very important to understand how we train and how we evaluate models.
Look, I added another question from Tadej Kurepa's list, okay?
Before that,
please,
I'd like to say that if and it is, the ChatGPT and other models being trained by us asking questions and writing prompts, I have this strong feeling since I started using model 3.5 in November 22, that answers we are getting now are of lower quality than answers of 3.5 model were in like November or December of 22, and that is so I think that if it is true, if it's not unrelated just feeling, is that because we are asking too many stupid things and we spoiled the model.
There is a famous cartoon, an internet meme, showing some sort of how to put it, embodiment of ChatGPT, a guy looking like this, and then with the word stating ChatGPT after 1 year of talking with humanity. It's like, not. So could be. I mean, it's also really complex to judge that, what's happening with the data drift, as we would call it. So feeding in, tons of bullshit to it, and then perhaps misguiding the training. We don't know about it. What I know is that the amounts of data that they receive from us are so massive that no one really, in OpenAI or anywhere else, will go through the whole pile and figure out, well, this is high quality conversation, low quality conversation. They might attempt to do some sampling, but the amounts of data are such that it cannot be really controlled. Look, Tadej, your question, what are the essential skills that employees need to develop to increase their job security in this new, and then I added, in this new generative AI-driven economy, okay? Just to, spice it up a little bit for our friend. So, what are the essential skills? My favorite questions. I mean, in the previous 2 years, there was not a single journalist that interviewed me on generative AI without asking me, are we going to lose jobs? And what's this thing going to do? Especially media workers are a little bit afraid of it, right? You know, I was always convincing them nothing like that is going to happen because I work with a company that works with media, and we know that basically you are, sad to say, technologically illiterate. I mean, it's the level of application technologies in media is far below what could be done there, right? So I don't think that people in media should worry too much, but everyone is asking about that. That's the hottest question: is what will we do to the job market? You know, so let's shoot this out. What are the essential skills that employees need to develop to increase their job security in this new generative AI-driven economy? So what does our competitors say? Let's see. No, they say good. Look, wow. Employees can enhance their job security by developing a blend of technical, analytical, and soft skills. Technical skills, AI and machine learning knowledge. No, I think it's missing the point completely. Yeah, it's like absolutely. So yeah, that's one thing that Branko now have observed. So everyone is asking us from the field of machine learning and AI, are we going to lose our jobs? And my response was often, have you seen that thing doing Python? It's doing it way better than English or Serbian. So probably we should be worried first about losing our jobs. So what does ChatGPT 4.0 suggest? So we should learn about AI and machine learning knowledge. I'm not sure. Data analysis, definitely not. Coding and programming. Look, this thing is fighting us. I mean, it's manipulating us. It's pushing us exactly into the abyss, right? Okay, learn to code. So automation tools, Mikhail, that's you. Cybersecurity, and then say analytical skills, problem solving, critical thinking, data literacy. Come on. Soft skills, okay, this is just you know, a roster, nothing else. It's just a compilation of thoughts. So adaptability and flexibility, come on, communication, collaboration, ethical awareness, AI model development, human interaction. No, it's completely missing the point of the question. Maybe I should have formulated this in a different way. In the evolving generative AI-driven economy, employees can enhance their job security by developing a blend of technical, analytical, and soft skills. So let's try and ask something similar.
I'll use the opportunity in the meantime while you type, and say let's go a bit in time before Gen AI. So World Economic Forum in 2021 had this forecast that 50% of all employees will have to enhance their skills in next 5 years. So the next 5 years from 2021 is 2026, and it's quite close now. So these essential skills, like skills for the future, are self-management, as in managing yourself. The second is collaboration. The third skill is collaboration with other people, like knowing how to work with your coworkers.
How to conspire against generative AI.
The third essential skill is problem solving. We see that Gen AI also lists that. And the fourth is use and development of technology. But what is interesting in these skills that only 1 out of 4 is related to technology. All other are actually soft skills that are related to understanding yourself, understanding other people, and knowing how to work with other people. Yeah. So when I wrote this, this was also a trick question, because I expected, you know, that the answer is we need to grasp the technology, learn to.
And that's what you got in the response, actually.
We need to learn to prompt engineer and so on. Okay, yes, but we need to understand people who we are working with. We need to understand our goals, our strategy, understand ourselves, and to, let's say, to create together a more stronger vector than we are now. I think this is. I would like to put focus on this.
And also the real human things, the real human skills, right? Look, I've tried to nudge this question of yours a bit. So in the evolving generative AI-driven economy, employees can enhance their job security by developing a blend of technical, blah, blah, analytical, soft skills, yada, yada, yada. Now, look what I would like to ask ChatGPT now. So what skills will not be automated by generative AI? What professions will generative AI not be able to replace? And let's see if it is even going to go your way, the way that you thought about it. So look, emotional intelligence. Okay, so as a psychologist, I have a kind of a love-hate relationship with the concept of emotional intelligence because I simply do not believe that anything like emotional intelligence exists at all. And no, that's simply a matter of, if you're a psychologist, especially if you're a theoretician like me, then you know that, emotions are one thing and cognition is something else. And then speaking about emotional intelligence is like speaking about unicorns, since it doesn't exist. But then again, the concept is used to, explain the elaboration of managing emotions, perceiving them, empathy, and things like that. So it is, in a way, it's intelligence, but not really. So anyways, emotional intelligence, okay, makes sense. The ability to understand and manage one's own emotions and the emotions of others is crucial in many professions, okay. Then critical thinking and problem solving, but that is actually the promise of generative AI, which will not be fulfilled, certainly not with large language models. They learn only by pure associative learning that will never really lead to reasoning, we know that.
But it is a promise.
It is a promise, but it's more of a market promise. But fundamentally speaking, we know that associative learning simply doesn't lead to a formal system, no formal symbolical system, no reasoning. That's it. So creativity and innovation. Generative AI can create new content, but human creativity, particularly in arts, design, and novel problem solving, remains unique. Okay. Leadership and management. Well, that is getting closer to your thoughts, right? Ethical and moral judgment. I couldn't agree more. And then interpersonal skills. So it seems to kind of figuring out that it should go into that direction, so that we are safe if we keep to non-technical skills, but more towards this really soft skills and managerial things, understanding people, as you were saying. So professions less likely to be replaced by generative AI. Healthcare professionals. Of course, it doesn't have hands, right? So it cannot manipulate anything. So creative, right? So that was easy. Creative arts. Okay, education and training. Oh, I'm not sure about that. Oh, since I have this thing,
it is powerful.
Yeah, you can turn it into a tutor whenever you like. Personally speaking, 90% of my usage of ChatGPT is I build an assistant. Here are the materials. Tutor me. I want to learn this new package, this new library, this new method. It's absolutely it's awesome.
But again,
it's
just
awesome.
Understanding what exactly you want to learn. That sometimes is a problem.
Technical
with people,
things.
yeah.
I don't want to run through the whole documentation. Show me how to do it. Here is the documentation.
No, in that case, it can do miracles.
And then social and community services. ChatGPT is obviously not interested in lower wages segment of the market. Okay, so skilled trades, professions such as electricians, plumbers, carpet. Okay, again, it's not a robot; it cannot do anything.
5 and 6 are great.
Legal professionals. I think we can always replace legal professionals by
Oh, hey.
Just kidding. And then human resources. No, first on the list. Right?
They will be gone very soon.
So enhancing job security, the advice is by ChatGPT is you need to develop interdisciplinary knowledge, build strong soft skills, staying current with technological advancements, and fostering creativity innovation, emphasizing lifelong learning, blah, blah. I still find this to be a lot of yada bullet point things and a kind of a roster or compilation. But then again, in the first part of the response, look, ethical and moral judgment, interpersonal skills, leadership and management, emotional intelligence, critical thinking, creativity, innovation doesn't fall far away, I would say, from your way of thinking. I know Tihomir was asking, so it's, grab the mic.
Yeah. So I was wondering how far until LLMs will be able to express emotions. Like if we have a current situation where we have tokenized words, like in 4.0 we have tokenized videos or images or whatever. So why not expect that the emotions in a way as a word representation will be something familiar to ChatGPT so that they'll be able to respond with human-like emotion level in a way. And also for the other bullet points, we might say the same. So do you think that tokenization will create a world model for LLM that will enable it to behave more human-like?
Not sure if I understand how do you relate tokenization to that. So
yeah, so basically to enable a model to learn not only what we currently have, like predicting the next word, but also to be able to predict the emotional response in a way to whatever input it receives.
Look, I mean, we have seen from the most recent OpenAI demo, the one that happened 2 or 3 weeks ago, that they're focusing themselves 200% on it. Okay, so that's the idea, to introduce the emotional modulation of the response, etc. So not me, I mean, no one knows. Do they do that with separate models, one predicting the emotional reaction, the other one predicting the next word? Or it's just the emotional modulation as such built in the LLM. So about the tech that they're using, I don't know, but obviously they're pushing that into that direction. And that's, by the way, if you read the Ilya Sutskever's reaction after leaving OpenAI, exactly what he said. So they're now obviously working on a shiny new product. They're not working on intelligence anymore. I want to do other things, right? Which I understand. They're polishing it up in order to be more human, right? To sound more human, okay? So yes, that will go into that direction. But the more important question when it comes to understanding emotions or really anything human is, will they ever develop a system which does not work by predicting the next token, but which works with planning? That's the essential part of the intelligence that is missing there. So predicting the 5th token before predicting the next token, that is what's called planning in AI, right? Because actually we know that when we use the language, we do not use language in a linear way. We just write in a linear way and we speak in a linear way, and that is a physical necessity simply because we live in in a universe which is temporally organized. So we cannot utter 5 words at once. We can simply serve one by one, right? But we know that a human brain does planning. Okay, so in the planning you can find that in neurophysiological findings from scanners. You can find that in psycholinguistics findings. So we know that we plan sentences, paragraphs, utterances, thoughts. Okay, so we fill in things that will happen in the future in a sense of we sometimes first know what will happen in the end of the sentence, and only that helps us formulate how does the sentence begin, right? Which is markedly different for what happens in LLMs, right? LLMs really predict only the next token statistically, right? Turns out that this might sound as something easy because it's not complicated to formulate as a scientific question. But on the other hand, when you enter the mathematical theory beyond it and the way how neural networks are built, you would easily figure out that it's a problem of tremendous dimensions. It's extremely difficult, right? I don't think that before actually struggling with that project, with that problem, right, of really planning, predictive planning, I don't think that anything like predicting real human emotions in a sense of controlling the discourse in a way that, you would talk to someone important. I mean, when I say important, I mean important in a sense of powerful business, etc. You know, with your kids, with your sister, with your friends, etc. When you're planning your emotions, listening to them, etc., which is all the part of the natural discourse. I don't think we will get anywhere close to it, right? We will be getting assistants which will sound human as they really sound in that OpenAI demo where they use the Sky voice, which they cannot use anymore because of who complained, not Taylor Swift, but Scarlett Johansson complained, right? Okay, that was too similar to her voice. We will get a sort of a simulation, right? That is what we'll be getting, right? A real emotional response, a real human discourse. As a psychologist, I have to say, I don't think that we are getting any near to that before we develop systems that can actually do predictive planning, right? That's what the brain does, right? These systems, they simply don't do it. So they're capable of, you know, detailed simulation, I would say, but the real control of discourse, not. And please, so I was warned about the time. It's 25 minutes to 7. We need to go get to a dinner. One last question, okay? So, Tihomir, sorry. Could you just pass the mic on to?
A pretty interesting idea about psychology and planning, but probably you have heard on the paper called Medusa, which enhances language models with the multiple heads that predict not only the next token, but the next token and like several tokens in advance. And it's used later to fasten the inference process. How do you think, is it like going towards what you call planning, or
No.
is it, why? Could you explain this?
Simply because we have mathematical proofs as old as the 80s and the 70s. And this is for the 200th time that I will be repeated in the previous 2 years. No system of associative learning ever, however powerful it is, will ever do it. Okay. Let's not elaborate now. We can elaborate at the dinner. There are at least 3 books that I can offer you where you can find the proof.
Goran.
So nothing which is of associative nature, deep, shallow, a transformer, a multi-head transformer, or whatever context reading thing will ever do it. You need real symbolic AI combined with that in order to do it. Simply that's the only way, you know, because there are only some limited mathematical functions that can be learned from associative learning, right?
Lights are next, right?
It's done. Sorry, they're throwing us out. Okay, so let's continue. Dinner. Željko, thank you very much for being such a nice host.
Thank you very much.
And thank you everyone for being with us.
Thank you, Goran, Branko, Tadej, and Mikhail.